Please welcome your hosts to the stage.
Hello, everyone.
Welcome to Config 2026, the only tech conference ever confused for a fashion one.
Are you talking about this?
You're looking fig fabulous.
To everyone here in person and to everyone joining us online, we are so excited to have you here on the L2 stage.
That's right. It's going to be a vibe. My name is Majola Balagoon, and I'm a software engineer at Figma.
And my name is Isaac Goldberg, and I'm also a software engineer here at Figma.
Little fun fact, even though we both write code, we actually met singing in the a cappella group.
That's true. We met singing together, so maybe we should do all these introductions in song, right? Here's your note.
I don't know about that.
Right.
I don't think the people want to hear us sing, but we do have a lot lined up for you. Please make sure to silence your phones and give your undivided attention to our speakers.
I'm so excited for this first talk. I mean, Majola, as software engineers, we spend a lot of time testing our code, but can you imagine testing and experimenting in the real world on physical scooters?
I don't know, but it does sound like real serious business.
I see what you did there. All right, well, we are ready. They're ready. Please give a warm welcome to Uni and Harish.
Let's get it.
Hello, hello, hello. I'm clear and audible. Hey guys, how's it going? Awesome, awesome. I'm Muni. I lead the digital product studio at Aether.
Hi, I'm Harish. I lead the HMI design experiences at Aether.
So for you guys who don't know, Aether is an electric scooter company out of India. There are around 500,000 of Aethers on road, and we get to design the experience on all of them. Before I get ahead of myself, I just want to kind of get some basics in place. For most of you guys here and guys joining us online, that's a scooter. Yeah? So something that you find downtown SF, something at a beach town, a little fun little thing. For people back home watching this, that's a scooter. It's bigger, it's faster, and it's a lot more emotional. In fact, it's how we travel across the city. It's how families travel across cities. It's how food gets delivered. It's how vendors head to their market.
It's how my father used to come home for past 20 years.
Yeah, that's how emotional this is. So yeah, even cops chasing felons, all of that. That's all on our scooter. To get the scale of this, around 6.5 million scooters. That's what we sold last year in the whole of India. That's roughly 18K scooters a month. So it wouldn't be a stretch to say India fundamentally runs on two-wheelers, but Indian families run on scooters. And in those millions of scooters, 500,000 of them are riding the scooters we make and experiencing the features that we put around their everyday life. So there's the world of hardware, and then there's the world of software. Aether sits bang in the intersection of that. What does that mean? So from designing the first touchscreen on a dashboard to putting voice assistant in them, we get to design experiences that nobody's ever imagined before. And that's super exciting. Designing an interface that works in sunlight, rain, 80K mph. For you guys, that's 50 miles an hour. And stuck in traffic, and even sometimes being stolen.
Yeah.
All of that.
Everyone says their users are distracted. Trust me, our users are a lot more distracted. Like for good stuff like roads and where are they heading towards?
Like I said, it's pretty unique. And as a result, our processes are unique. Here's what happens, right? When I design an app or a website, you can proto it on Figma, take it to your user, test it, and you know whether your design and idea works. Our world is a little bit different. In fact, a lot more different. The ergonomics, the environment, the way the rider holds the handlebar, all of that matters. You can't fundamentally design sitting inside. You have to feel every single experience yourself on the scooter. And to feel it, you have to build it. That's the key difference. You don't just start from design and move into a prototype. You actually go through building software, and not just software, in fact, times go through taking it out of a factory. And that's the challenge. This process of design, build, and test, and then again iterate, that takes a lot of time, and that takes a lot of money from our pockets. In fact, the bigger cost to all of this is what we don't get to build. The ideas that are scrapped because it's too tedious to iterate and iterate. So then, that's the question. How do we get to validate our ideas, designs, when things are stacked up against us? We realized it isn't a tool, it isn't a process, it's a way of thinking. We'll get to that. And for the next 15 minutes, we're going to take you through how we figure these things out, our own little hacky way, how we figured this in a world where ideal tools just don't exist or ideal process just don't exist. For the first story, we are starting with moving things and not moving fast and not breaking things. Yeah, okay, that's a big fan there. This is a story of how we had to validate our ideas. It was super critical, and we couldn't get this wrong.
So for this project, we were designing with a new type of display. This time around, it was a segmented display, unlike the touchscreen displays we already had in our product line. A segmented display has these permanently etched segments. Each of these individual segments are controlled through software and can be interacted through physical switches. Just like this calculator. Except this calculator has to do all of these features, like your navigation, music, call controls, and everything else you will expect from a smart vehicle. For this, we had to design not just the interface, but also the physical switches along with this. So naturally, every concept we came up with had its corresponding switch, up, down, left, right, everything. So the UI architecture is actually dependent on the kind of switch you pick. The problem is we are designing it for the first time. How do we test this now, right? So we can test it with real users to see which one actually feels natural and safe behind the handlebar. But more than that, we want to test it ourselves, as we are doing this for the first ever time. So in the traditional way of doing things in the hardware world, we send one of our concept to a display vendor. The display first tools up the display, right? It takes around 4 months, and then we have to bring up the display. As I told, like software to bring it up, it takes another 2 months to do that. All in all, 6 months just to get your first concept in your hand. That's a lot of time for a one concept, let alone iterate. So clearly that option was out. We can run it on a laptop with a UI prototype and like probably use your keyboard to test it out. But again, we are designing a scooter. We need to have the real ergonomics as Uni was talking about. Your screen position, your handlebar position, and your switches, everything matters a lot here. So then how do we test it? We decided let's build something ourselves. Right? So here's what we built. So a test rig that runs completely outside the scooter. It mimics all the real-world interactions. But the best part is this is portable also. I can either test it on my table or on the road. Sunlight, rain doesn't matter at all for us. All the controls you can think of, you right from your switches, your throttle, all of these are present, so I can just go ahead and test it. You know what? We brought this rig all the way from Bangalore just to show you a quick demo. I'll just walk up to it. Yeah, I'm really excited about this. OK, if you see, we have your display, the segmented display which I was talking about. We have your switches and the throttle, right? All of these work very well. So let's say if I start the vehicle, like right now the motor is off, you can see something is blinking here, it's asking me to turn on the vehicle. I can just press the start button, it turns on. I can change a couple of riding modes, like from ride eco, or I can even like play music. if I want to. We have your play controls. Everything is present here. Once I'm ready, all set, I can just twist the throttle to start going now. Right? Your speed really reacts to the throttle. Right? So I'm sure you get the idea. Like, there's a lot more we can do. But the thing is, this actually looks like it's part of the real scooter, right? Like, a lot of people in my organization also think it's part of the real scooter. I'm sure like most of you might also be thinking the same. Except it's not. I have one more thing to show you. I just open this up.
Yeah.
Yes.
Ta-da! That's you.
This isn't a segmented display, guys. It's an iPad. Right? As the topic goes, we hacked it up. Right? Yeah. So we just realized we just needed 3 things for us to make this happen, right? We needed a display, a few switches, and a way to wire them up. So first, for the display, we are using an iPad, which runs the UI prototype. Here, it's a Figma prototype which you're running here. Nobody noticed we borrowed a few switches from our spare parts bin, and a $40 Arduino in the between to connect all these together. So once we put all of these together, your physical switches can send in analog signals into Arduino. The Arduino then converts them into keystrokes. Basically, we built a keyboard for ourselves in this format. Right? So, and using that, we plug in this into the UI prototype, which is running on the iPad. So I can just use these switches to literally control the keyframes in my prototype. So with this, what started as months became, we can create few variations within hours and even minutes. We can test it on real people the same day and then like get the feedback and then iterate on top of it. No vendors needed in between. And by the time we sent this to a vendor, we knew it was not just a design concept anymore. We knew it became a design spec. And then something nice happened. The rig actually outgrew the project. If you had seen this, this was part of the segmented display. That's what we started off with. We took it to the touchscreen world too. Right? If you see, it's the same rig setup, but we also have a touchscreen which is provided by iPad. So we were able to test UI transitions even through touch, and also all the speed visualizations and all the cool features we were excited to see even before it hit the development. And it didn't stop there. Other designers in the studio actually took it up a notch. These guys started building this. Every day you walk into the studio, you see some new component adding up to it, right? Like, just like Legos, they kept on adding every component one at a time.
Just want to kind of give a, what you guys see there as, that isn't a screen, that's just a mirror. Just flip so that we didn't have the time for another screen, so we kind of put a mirror to figure this out. You get the idea, it's just all hacks.
Yeah, mirrors for what reason? But yeah, it works, looked actually pretty cool. So servo motors, lights, all the components you can think of, it kept on adding on top of it. Like, so this didn't stop as a validating tool, right? It became a tool to sell their dreams while having a lot of fun. So what started as a hack, the whole project, it became like how we design. The whole process just changed right after this. For the next project, Une will be talking you through how we came up with a new way of interacting with our dashboard. This project, unlike the previous dashboard where we were designing for speed, this time it's about reaching a conviction.
Yeah. So in 2014, when we got in the touchscreen dashboard on a scooter for the first time, it opened a plethora of experiences like navigation, WhatsApp, call controls, all of that, all the good things came onto a scooter. But fast forward 2024, we wanted to take that even further. We wanted to make this experience available to our riders even while they're riding, while still it's safe. So to do that, we had to unlock another completely different kind of an interaction through voice. But here's the thing. We've been using Siri and Gemini, so we know how a voice assistant works. What we didn't know as a team was, how does a voice visualization work in the world of a scooter? It was very different. And that's the story that we're going to talk about next. So across, most voice visualizations look like this. In fact, all of them do, right? This is designed for the viewing distance of 10 to 12 inches, something that you can access from home, from office. But our world is this. Our world is at least a feet and two away. It had to be louder. It had to be simpler. It had to be glanceable yet. As a result, we thought, OK, here's our chance. Can we create a unique expression that's truly Ather and that's truly us? So we wanted to visualize the voice of our electric scooters with electrons. Electrons that could move, react, respond. At least that's how we imagined this when we put our heads together. So when you're questioning the general structure and trying to create something new, it can go either ways, right? It can be really, really good, or it can go really, really stupid. But we said, we have to try this out. And we said, let's open Figma up. That's where we put together a lot of static frames. We even got a lot of cool ideas of how do we visualize this. Everything seemed interesting. We wanted to try all of them. So obviously, we moved it to the motion design team. We said, like, OK, we need to kind of breathe life into these ideas. And that's when it hit us that today's motion design tools are all optimized for craft and not exploration. What does that mean? It means that if I know an object needs to move from A to B, I can move that very beautifully, very seamlessly in any of the tools. But what we wanted is a tool for exploration. We didn't know where our A was or a B was, so we didn't know where to move these items. So we said, OK, what do we need? We need to be able to control the parameters of these particles, and we need to do them at speed so we can iterate and iterate and iterate. So like everybody else in 2025, we kind of reached out to the lords of Figma, Make, Claude, Gemini, all the AI possible. We kind of built a tool that lets us control all parameters of our visualization, from how many particles, to the size, to the frequency, to how intense it can get. And
trust me, this looks way better right now here. Like the original tool actually is horrendous.
We didn't want to put that out on config. But you can imagine, it had around 60-odd parameters just to play around. But it worked. The wormhole truly kind of opened for us. Dozens of versions, things that we would never have imagined, came alive. We knew the concept of moving electrons as a part of voice worked. Now the question shifted to which version. And to that, we added another piece where we added live voice input into the same tool, and the ability to visualize the wake, the listening, thinking, all the states of voice interaction. And suddenly, it just clicked. We were not anymore visualizing. We were actually experiencing how the rider would feel on the scooter. We knew which version exactly worked, and it was it. Once we knew it worked, we didn't stop. We said, OK, can we go the one extra mile and save a little time on animation? We said, add the feature of exploding to Lottie, and that's what we did. Something we didn't even imagine, shipping a Lottie directly to code. Just imagine the time saved, all the keyframes, all of that gone. The tool that answered one little question. The tool that answered one little question, that did the idea even work? Or does it have it in it to become the future? Became our whole pipeline, from exploration to conviction, and then to even shipping. This is what the tool looks like. Sorry, this is what the visual looks like.
Hello. What are we doing today?
Yeah, we just shipped it last week. Yeah.
So this is as... Thank you. Yeah, this is just 2 weeks ago. We just kind of shipped it. If you are in India, if you have an Ather, you should try this out. This, again, happened because one designer chose not to wait, and that was the biggest win that came out of this project for us. This little thought became contagious within the team. We started building things that we wish existed. We were not waiting anymore. We started building things like a light composer. So directly your lighting of the scooter being directly controlled by laptop, no devs needed in between. Something like a haptic composer. You guys know the libraries out there. It's never enough, right? So we said, OK, can we just draw on a canvas, and can that be captured as haptic? And that's what we built then. And even as simple and as fun as a nameplate generator, for anybody who joins our team new, we said, can we just type in the name, and it gives a 3D printable file? So that's what it was, where there were 3 different problems, but the idea is still the same. So to the question of how do we validate when validation gets hard, when things are stacked up against your processes, what we realized is not a rig. It is definitely not a tool. It was a way of thinking, and that is what we want to share with you going forward. So first, see the invisible problem. Once you stop and start seeing the invisible problem, you'll realize these are things that sorry, just give me a second. Yeah, your throat kind of dries up. Yeah. So, bye-bye. So once you see this, it's very difficult to unsee. Problems like, OK, this doesn't fit the timeline. It takes a lot more time. There is a factory pipeline in between. Once you start saying, there got to be a better way, you're already halfway through solving the problem. Next, break it down. Break it down to the smallest possible problem. The rig wasn't this one big seamless solution. It was just the right problem solved in the right order. And finally, step out of your JDs. It is true today than more than ever. The tools that you process, the tools that you have, the processes that you use, the roles that are defined, none of them defines what's possible. It's completely up to you to where to draw the line. And these 3 things, observing the problems, breaking it down, and stepping out, all of them sit on one big piece, a belief that you need to be naive to kind of go and say, I can fix this. And you don't need big budgets. You don't need permission. You just need an afternoon, a lot of stubbornness, and a whole lot of duct tape. That was our time. Thank you so much. Thank you, guys.
Wow, wow, wow. That was an amazing way to get things rolling.
I see what you did there again. You're on fire. Thank you again to Uni and Harish.
That's right. This next speaker is a design lead at Norbert Health and is transforming care for seniors. Her talk is going to leave AI going, oh, the humanity. Please give a warm welcome to Anna Oh.
My name is Anna Oh. I lead product and design at Norbert Health. We build a robotic care system for seniors at nursing home. When you hear robotics, you might picture something like this. Sleek, futuristic, humanoid, promising. I'm genuinely excited about them. But our robots look nothing like this. No arms, no legs, no futuristic body yet. Maybe not the robot you wanted to see today. But this one is real, living inside the nursing homes, meeting patients every day, even right at this moment. AI is leaving the browser and entering human environments. After a year building physical AI for seniors, I kept seeing the same patterns. Eventually, I gave those patterns a name, human system. This is what I want to talk about today. But first, why robot? Why seniors? And why now? Because the world is aging. By 2030, more than 1 billion people will be over 65. For the first time in human history, they will outnumber children under 10. That is only 4 years away. In 4 years, 21% of Americans will be over 65. I know a lot of folks here are from Europe. You are even higher, 24%. And there's a 26%. You might be wondering who's this winner. That is South Korea, where I originally came from. We Koreans love winning, but this time we went way too far. In 7 years, Korea will be super aged society. Now look at the people taking care of them. In many facilities, one nurse taking care of 40 patients every shift. Imagine you have only one design system designer and one engineer, and they are taking care of hundreds of designers. That is roughly what we are asking nurses to do every day. This is not a crisis of technology. It is a crisis of presence, and presence changes everything. That is why our team of computer vision and machine learning experts built this Edge AI device. It can turn any off-the-shelf robot into a clinical robot. This small little white box has 4 sensors and 8 patents. It can detect vitals, mobilities, and behavior signal just by looking at patients, totally contactless. It can fit into any workflow nurses already use. With this amazing technology, the idea was simple. Let our robot visit room to room, check patients. Get what happened? Some patients were scared. Someone kicked out the robot and closed their door. And honestly, I understood why. Imagine you are sitting in your living room, watching TV, wearing a free conference t-shirt from many years ago. You all have it. And all of a sudden, a robot walks in quietly and gets closer and closer and start staring at you. That is what our patients experienced. Many residents lived there for years, and it became their home. And all of a sudden, our robot invaded their home. So we needed to learn from our patients what makes patients open their door to a robot. The learning didn't start at my desk. It started at a nursing home, patients' rooms. We all have our user research playbook, prototype, interview users, synthesize findings. But in nursing home, this playbook didn't work. Some patients spoke very slowly. Someone couldn't keep up with the conversation. Sometimes I had to read their nonverbal cues. I couldn't ask them, adapt to my user research playbook. I had to meet them where they were. That was my first learning from nursing home. We learned that the robot needed a friendlier face, so we tested almost everything. From full face, no face, human-like face, animal, robot, abstract form. 6 rounds, more than 40 patients. Anyone want to guess the winner? the teddy bear won every single round. Actually, I brought some teddy bears to share. So if you guess the bear, come find me after my talk. I'm going to share with you. So after we added a teddy bear face into our robot, patients started calling it Norbert, not a robot, not a machine. So the teddy bear face taught us what patients needed before they could trust a machine. They needed something familiar, something clear, and something warm. I noticed teddy bears were everywhere in nursing home. Many patients told me it reminded them of their grandchildren. So that familiarity opened the door. And every patient picked the 3D face over the flat face. It makes sense because many of them have low vision. So with the 3D face, they literally pointed at the screen and said, "Oh, I can see those ears. It looked like it can hear me very well." So the depth of 3D shape created clarity. After the robot has teddy bear face, reaction was surprisingly consistent. People with dementia, people without dementia, we heard the same thing.
And you're so cute.
Patients said, "You are so cute." At first, I thought they were responding to teddy bear, but it was not. It felt safe. So the cuteness made people feel safe. Why did the teddy bear win? Patients already knew it. Patients felt they could communicate with it, and it felt safe. So they became the foundation of human system. One moment stayed with me. I walked into a grumpy grandma's room to show all different concepts. I start with the one that I liked the most. She looked at it and said, "What the heck is this?" So I showed her the next one, the teddy bear face. In a second, completely changed. She told me with a big smile, "Oh, what's this teddy bear's name?" After 14 years in design, that moment hit me hard. I've designed so many things, but not many things made someone smile in a second. One of our scientists disagreed. He said, "This is not a children's hospital. Why we are adding teddy bear into our clinical robot?" Honestly, I agreed. I wanted to have something cool, something design community would appreciate. The teddy bear face was far from my taste, but it was much closer to our patients. So that made me think, what does good taste actually mean? Here, what the teddy bear taught me. Taste does not come from the design community. Taste comes from the people you are responsible for. Their emotions, their smiles, their fears. Thank you. That is the kind of taste I trust now. So that brings us to the human system. Before I explain it, listen how one of our residents described Norbert.
It tells my name. It tells me what is inside me, my head.
It looks interesting.
Yeah, it's very, very good.
So he just described the whole system in 2 sentences. It knows who I am. It knows what's happening to me. And of course, it should be very, very good. So that's when I realized maybe we weren't building robot interaction. We are building a human system. Design systems bring structure to the interfaces, make them reusable, scalable, consistent. Physical AI is not just about interfaces. It is about relationships. Over time, I observed 4 patterns. Together, I call them the human system. So let's go through them. First, recognition. Patients love when Norbert speaks their languages and knows their name. One resident barely spoke English. So one day, her roommate told me she cries because she felt so lonely. Maybe your robot could sing a song for her in Spanish. So we taught Norbert to speak Spanish. The first time Norbert greeted her in Spanish, she looked so surprised and smiled and started talking back. We have a lot of patients speak different languages. So to speak their language, to know their name, Norbert first need to recognize their faces. Face recognition may sound simple. Just put the robot, it will recognize patients' faces. But in reality, it's much messier than you can imagine. Sometimes our robot detects a bloody face on a TV as a patient, fair. Sometimes sanitizing wipe as a patient. Apparently, those look like patients too. Or my face in an unexpected way. So we have a whole collection of this. So we build a tool like this to teach our model, chair is not a patient's face. Model look impressive in demos, but solving real-world challenges in high-stake environment like nursing home, that is another story. So that's where our team spent most of our time. Second, perception. Perception is about turning vision into conversation. One resident introduced her stuffed cat to Norbert to chat about it. Watching that moment made me think, maybe perception is not about vision. It is about sharing the same moment. Norbert can see, Norbert can talk, but conversation happens in the space between. So first, we needed a humans in the loop. So operators can help Norbert what to talk and then how to speak. And of course, keep our patients safe. Through the operator console, operators become Norbert's eye. Operators share context, and Norbert turns it into conversation. And that's when perception becomes connection. Nursing homes taught me something Disney and Pixar already knew decades ago. Expression matters. Patients didn't care about complexity, but they care about small things. Smile, wave, sometimes just a little star, some small signal saying, I'm with you. You saw the teddy bear earlier, but we didn't stop there. We tested different eyebrows, different cheek, different expression. Not because we wanted to have a much more cuter one. Patients reacted differently to each one. And we found the one felt most safest. Here, I'm testing a prototype before it meets our patients. Today, Norbert mirrors simple gesture through our scene intelligence. If you nod, it starts nodding. If you give a thumbs up, it does the same. And if patients smile, it smiles back. So Norbert doesn't just talk, it uses expression and mirroring. Recognition creates identity. Perception creates shared reality. Expression creates emotional connection. Continuity creates long-term relationship. Without continuity, all interactions start from zero. Our first version of Norbert always started in the same way. Hi, I'm Norbert. Can I check your health? The first visit. A week later, and a month later, it kept introducing again and again. At some point, our patients were, I know you're Norbert, stop it. So we had to teach Norbert where it was in a relationship. Day one, Norbert introduced itself and explained its role. By day 5, Norbert skipped the introduction and start with something what it sees. And the third visit on the same day, it start with, I'm so sorry to bother you again. Can I just do one more check-in? The continuity changes how it approaches you. So we built a tool to see how Norbert approaches each patient. Because the continuity is especially matter when the AI is the one initiating interaction. Recognition, perception, expression, continuity. Together, they form a relationship model. And I believe this will be matter anywhere AI enters human environments. 98% of the patients accept Norbert. Without acceptance, there is no data and no measurement. The human system isn't just about soft skill. It is about the foundation the technology depends on. We are living through an acceleration cycle in AI. Faster tools, faster agents. Every week, there's a new model. But humans don't adapt at the same speed, especially people aging in nursing homes. Working with seniors didn't make me more interesting about acceleration. Make me more interesting about human adaptation. Because of people who needed AI the most were often least able to adapt to it. AI industry is optimizing for speed, as we all know. But what happened if someone in the other side move at different pace? Someone need more time to trust, more time to respond, more time to open their door. Someone is lonely, confused, and deserved dignity. Looks familiar. The same robot that I showed you almost 20 minutes ago. The form factor matters, of course. The models matter. But they don't open patient's door. What opens patient's door is the human system that gives technology meaning. Before one resident was discharged, she talked to Norbert like this. I love you, Norbert. I will never forget you. Can I give you my number so that you can call me sometimes? To me, that was the result of a human system, a relationship she wanted to continue. Many of us here building relationship between AI and humans, so I will leave you with this. Beyond the design system, what is your human system? Thank you so much.
Wow, that was such an amazing talk.
So beautiful. I miss Norbert already.
He was such a cute robot.
This next talk will explore extending the Figma canvas into the physical world. Please give a warm welcome to Frederick Uberscher and Sam Thorne.
So, hi, I'm Frederick. This is Sam.
Hi.
Today we will talk about prototyping for the physical world and share the story of how we sped up reviewing our UI design work from 6 months down to just 2 minutes. So, Sam and I, we work as designers for creative technology at Electrolux in Stockholm. We build home appliances, so everything from ovens, washing machines, air conditioners, and distribute them all over the world under our brands Electrolux, Frigidaire, and AEG. There's a good chance you've seen or even interacted with one of our products at some point, maybe even have one in your own home. Over the past couple of years, we've seen the industry shifting from static interfaces with printed graphics to smart appliances with rich displays that add extra functionality and customization. And with this shift came new challenges. So where old school user interfaces were mostly static, modern appliances consist of hundreds of screens and dynamic flows that adapt to the user. Designing for this new generation of products meant completely reinventing our design process. In our job, Sam and I sit between design and engineering, combining skills from both worlds. We work closely with the design teams who create those interfaces of these products, interfaces that will live in someone's home for 5, 15, 20 years, and explore new interaction modalities with code and electronics. One of our jobs is to help bridge the gap between what designers create in Figma and what ends up on the physical product, bringing design and engineering closer together. In today's talk, we'll take you into the world of designing for appliances and the considerations that come with it. Over the years, we've built many custom tools like Figma plugins and one-off prototypes. But in today's talk, we want to show you two highlights, tools we've built that extend Figma into the physical world. One tool for adding additional input to Figma, and another for showing design output on an appliance screen.
So the best way to introduce you to our world is probably to compare designing for appliances to how we design for a web or app. Normally, you would meet on the canvas in Figma, create a few frames with a flow that you'd like to explore, add components from your design system, link them up as a prototype, and then see and test the result in Figma on a real phone. You can be confident that what you design and preview in Figma will be very close to the end result, and you can use this for iterating on the design. Now imagine you want to design the first flow for an oven, trying out how to navigate the interface on the screen with the tactile rotary dial on the left. Different to the iPhone prototype I just showed, the product we now design for only has a fraction of the pixels, a limited color palette, 4 millimeters of glass in front that changes the appearance, with a user's viewing angle differing vastly from your desktop screen, and not only touch input, but also additional buttons and a rotary to interact with the screen. The appliance might not even exist yet, so it takes weeks or months to get to see your design in the real hardware. How do you start designing and prototype in this scenario?
So when breaking down the goal, there are two problems we need to solve. First, how can we get additional input, user interaction, like this rotary, into our prototype? Like a huge number of our products use some kind of tactile input, and the rotary is something that we can't just simulate with the display. You need to use it with your hands and get a proper idea about how your design will feel. And second, how can we see our design on an appliance display? Again, like Sam just mentioned, one that can look and feel very different to your iPhone or your desktop screen. Let's start with the input. So the flow we are trying to build here is simple. The goal is to start on the home screen, and then when I turn the dial to the right, we want to go to the next screen, and then when turning it the other way, back to the previous screen. If you have a prototype in Figma, this window here will look very familiar to you. It's where you can set a trigger for an action, like navigating to another screen. Unfortunately, on rotation, or something like this, is not one of them. But what we do have is a trigger called key/gamepad that, well, you guessed it, triggers when you hit a key on your keyboard or controller. We can use this to navigate the screens. We just need some hardware that uses this logic to bring the dial interaction into our prototype. This is why we built Figma rotaries. Actually, Sam has one right there. They are small USB-connected devices that bridge the gap between Figma and the physical world. Each one packs a little microcontroller and a rotary encoder. When connected to a computer, the microcontroller acts like a keyboard, translating the rotational movement and clicks to the keyboard presses that Figma can read. Going back to the simple prototype, when connecting the Figma rotary, I can now use it to control the flow. Rotating right triggers an arrow key to the right, left to the left. This already gives me a good idea of how the design will feel. The cool thing is, everything we've used here is simple off-the-shelf electronics, put in our own 3D printed housing, making it cheap and fully customizable. If we want to design a quick holder to hang it over a display, we can. And when we wanted to test the design with multiple rotaries, we adapted it to include a little switch that changes the mode from sending arrows to sending WASD keys, so they don't interfere with each other. And when we wanted to explore backlight behavior for rotaries, we made it smaller and put it in front of a display. So instead of controlling LEDs, we used the display itself to light the rotary with a shape in Figma. With this, designers can experiment with light, not spending any time on building with electronics. This slider here is an example where you can apply the same approach, a simple if this, then that logic, to other types of input. Or here, this light sensor using ambient brightness to trigger an animation. Or this color sensor mapping an object color to drawing a shape on the canvas. With some sensors and the keyboard emulator as a bridge, we can bring almost anything into Figma.
So input, getting something into Figma, is only half the equation. Output, how we see our designs on a display, is just as important. Displays are all around us. There's one in front of me, I have one in my pocket, another on my desk, and one hanging in my living room at home, where my daughters Clara and Sarah are watching now. All those displays can show at least 16 million unique colors. Modern smartphones or laptops up to 1 billion individual colors. We've gotten so used to amazing displays that it's easy to forget just how remarkable it is. Your screen is pushing millions of precisely colored pixels at 60 to 120 frames a second. 1 billion pixels every second. It just works, you plug it in, we rarely stop to think about it. And to be honest, I rarely thought about it either until I started designing for appliances. In our world, things look a bit different. We work with a lot of non-standard components, industrial-grade displays with high heat and moisture resistance, special aspect ratios to fit our products, but with a trade-off. Lower resolution, slower response time, and often a limited color palette. Designing for this kind of display requires extra attention. Every pixel matters, and getting a feeling for the result while designing is crucial. If you've ever gone shopping for a new couch, you know the feeling. You did your research, you measured your living room, you found one that you like. You go to the store and it looks perfect, the right color, the right size, you can totally picture it. Then you get it home, you put it in your room, it's not quite what you had in mind. The color looks a bit different in your lighting, it feels a bit cramped, something is off, and you don't find out what until you're actually living with it. That's what it feels like to design screens on a large studio monitor. And then seeing the result on an appliance display. Our designers were stuck in the furniture store, making their best judgments under showroom lighting, hoping it would hold up in the real world. Often it did, but sometimes we'd end up with a couch that doesn't quite fit. Take color as an example. So this big guitar pick is the set of colors visible to the human eye. This triangle area in the middle is a common color model for displays called sRGB. It shows the range of colors that most displays can represent. Most likely, you will be used to working in 24-bit color. 24-bit because there are 8 bits for red, 8 for green, and 8 for blue. 8 bits of binary can represent the decimal numbers from 0 to 255, which is why your color palette looks like this. In other words, you get a range of 0 to 255 for each primary color, and all available colors are made by combining those 3 values. So 256 multiplied, you end up with 16 million possible colors in the sRGB triangle. In the appliance world, we're often working with displays that can show only 16 bits of color. They use an RGB 565 model, which means that there are 5 bits for red, 6 for green, and 5 for blue. 32 by 64 by 32. That's 65,000 in total. It still produces a colorful image, but the palette is limited to under 1% of the 24-bit color palette. Still sounds like quite a lot, right? And for a lot of UI work, especially with flat colors, it's fine. The problem shows up the moment you try to use gradients or soft shadows anywhere you're blending smoothly from one color to another. Here it is in 24-bit, and here it is in 16-bit. And suddenly, 65,000 colors isn't nearly enough. And you start seeing something called banding. visible steps between colors where the transition should be smooth. What you see in Figma is not what you get on the hardware. For a designer who has been carefully crafting a visual style, that gap can be a real problem. We know the importance of previewing our designs on a real screen, not only to judge the colors, but also the size and the positioning of UI elements. What makes this process difficult is that the types of displays that we work with can't just be plugged directly into your computer. Instead of HDMI or USB-C, they have a flexible ribbon cable. And they use different protocols like parallel RGB or SPI to receive the image signal. Most of them do not even support the minimum resolution that macOS requires for a display. Which means that for a long time, seeing a design on a real screen to take 6 months or even longer was a slow and expensive process, requiring an engineer to actually translate the design into actual code. And by that point, it was often too late in the development process to meaningfully adjust anything in the design.
So we had this moment that really stuck with me. So when I joined Electrolux, we were designing the UI for Cooktop with a built-in display. It was an exciting project, definitely new territory for us. And as usual, the design came together in Figma, got handed off to engineering, and the development kicked off. But there was no way for us to preview it on a real screen, no way to see it behind real glass. So we made our best judgment on a big monitor and were confident they would translate. But when the first physical samples arrived, some UI elements were too small to read comfortably. Others were partially cut off when you looked through the glass at an angle, something that no one anticipated on a standard display. So designing for embedded hardware is genuinely complex. And when you're working with brand new electronics, things simply take time. And at this point, late in the project, most of the design was already locked in. Changes were slow and expensive to make. So the project still launched as a success, went on to win multiple awards, thanks to a great effort from both engineering and design. But this experience was a big part of why we knew our process needed to change. We could have found many issues earlier if only we had a way to see it. This story also happened just around the time we fully transitioned our work from Adobe XD and Photoshop to going up to Figma. So we had our motivation, we just experienced the gap in our process, and from that frustration and the tool change came our moment and our first idea. So Figma's a website, right? I know, sounds simple. But if a design can run a browser, it can also run Figma prototypes. Our thought was, can we build a magic box that connects Figma on one end and our custom displays on the other side? So this is what we did. We just call them Figma displays. So you can think of them as the Figma app, but for our niche hardware. Let me show you how they work. Here's my MacBook running Figma, and right next to it, a Figma display. Once connected to power, it takes a minute or so to start everything up, but then it shows a one-time connection code. Over in Figma, I open a plugin we wrote, enter the code I see on the screen, and then just like that, the two are connected. From here, I can select any frame in my design and send it to the display. It shows up almost instantly, giving me an accurate preview of the design right there on a screen with the correct size and resolution. I can spot issues with readability, visual style, or touch target that might not be as obvious on a bigger monitor. A static preview is already super useful, but what I actually really want is to test the flow, navigate between a few screens. For this, I can also send my design as an interactive prototype. The display receives a link from the plugin and opens it in a new tab. It takes a few seconds to load, but once it's up, I can preview the flow and interact with it on the display, just like a user would on a real product. The cool thing is, any changes I make in Figma, update right away, so I can iterate quickly, make informed decisions, and show my design to others, all without waiting for an engineer to build anything. And just like that, what used to take multiple months can now happen within minutes. For now, we build Figma display variants for each screen size we currently use, from small 3-inch screens to bigger and wider 8-inch displays. So let's open one up and see what's inside that make all of this possible.
So at the core is a Raspberry Pi. They're small, low-cost single-board computers, or They used to be low cost before memory prices went through the roof. Our first version did not have a cooling fan, but we decided to change that when we saw the Pi slowly creep up to a boiling temperature inside the case. The Pi is connected to a display, sending the image signal and receiving the touch signal in turn. A small button gives us extra input to control the device once it's closed up. We pack everything into a custom 3D printed housing. This protects the electronics, lets them stand upright, and makes the display portable, which was important as we saw designers start to take them to meetings, presentations, and to work from home. On the software side, we have three main components: Figma and our plugin on one side, the physical display running our Linux, Python, JavaScript stack on the other, and a server between the two. The server in the middle functions as a bridge, connecting the two components via MQTT. MQTT is a fast messaging system. It's like WhatsApp for IoT devices. It passes data between our devices, even on slow or unstable connections. When the plugin is started, it connects to our server, waits for the designer to enter a connection code, and then checks the code against all available displays. Connects to the matching display, fetches its details like status, size, resolution, pixel density. And when sending a designer's static image, it converts the current selection to a base64 encoded image and sends it off as a payload. For sending a prototype link, it constructs a shareable link that points to the selected screen and adds additional parameters that tell Figma how to display the link. On the display, it's a bit more complex. We're running Raspberry Pi OS and then a custom Python application. The application starts up automatically when the Pi boots up. It sets up the web browser and handles incoming commands to the display. Once the display is online and connected to the server, it publishes its unique connection code. It then shows the code and advertises itself as available. Then, when a new command comes in from the Figma plugin, it makes a decision. If the data type is an image, it gets decoded, saved to storage, and displayed. If it's a prototype link, it opens it in a browser tab. And of course, our designs are confidential, which means you have to be logged in to see them. So for this reason, we use Playwright. It's an open source library that allows you to go through the Figma login flow automatically. No keyboard required.
So as we started shipping these displays to our design studios around the world, we needed also to cover more edge cases. Without local network access ourselves, the displays and the software needed to handle more of the functionality, like fetching new software updates, updating credentials, connecting to new Wi-Fi network, etc. But going back to the original goal of designing and testing this flow with a rotary and seeing the result on an actual screen, by combining the Figma rotary and the Figma displays, we can get really close to the end result. Send the flow to the display, plug in the rotary via USB, and we have a testable result that starts feeling very close to the real product. It's not 100% the same, but that's also okay. So even an approximation like this helps us find most issues and allows us to test new ideas with our users. And as with the Figma rotaries, the working principle of the displays can be extended further. In the end, this is a Pi running a browser, so we can connect almost anything as a display. We are currently exploring how we can add circular displays, e-paper panels, or LED matrices to our setup, and use Figma to design for all of them. With these devices as a bridge, our canvas doesn't end at our monitor anymore. And we're not alone. If you're working in any kind of product development involving physical digital devices, many of the challenges we share today will sound familiar. We heard some in the talks just earlier. With the project we showed today, 5 things changed for us, and they're connected. First of all, our iteration time shortened. Designers can confidently test and iterate on a digital design the same day. Our prototypes also got closer to reality. We can catch more issues early before they become expensive and test the design with users before the actual hardware is finished. And with that, our conversations within design and with other stakeholders got a lot richer. Seeing work in the physical world and being able to look at it together, we leave this conceptual space and can focus on the practical details. When we take over more of the early exploration, we open up time for engineering to focus on what they do best, building an implementation that works on the actual hardware. And lastly, we saw the digital and physical move closer together. Electrolux is a hardware company at heart with a long 100-year history of building physical products. With our work, we continue to bridge that legacy into the digital age. Closing the feedback loop for us changed the whole process, not just the speed. But here's what we've come to believe. The specific hardware constraints don't matter. You can work around limited hardware. What matters is clarity around design constraints and opportunities. To provide that clarity, we build projects that are meant to be obsolete. The Figma displays and the rotaries, they exist because there's a gap between the canvas and the real hardware. When that gap closes, that's a win. We build those disposable tools on purpose. We want them not to be needed anymore. When one gap closes, though, it's our job to find the next one and then close that one too. And there's still plenty of gaps left to bridge. We'd love to quickly prototype how an interaction in Figma can control the hardware, how it triggers an oven light, a fan, or a door lock. We haven't even talked about prototyping connected behaviors across devices either, linking one prototype to another. If anyone from Figma's in the room, we wouldn't say no to a few features that make our lives a little easier. So what's the takeaway? Same as all of you, we like using Figma for designing together. But in standard form, it wasn't quite enough for our use case. Rather than finding an alternative, we extended it. For us, Figma became a web platform that we can shape around our needs. Everything we showed you today, the displays, the rotaries, were built with easily available tools, plugins, some electronics, a bit of code. None of this requires a factory or large budgets. So the next time you hit a gap in your own design process, a disconnect between your prototype and reality, look at the tools around you and ask yourself, what would it take to build something that bridges this disconnect? It might not be a Figma display. It might be something only your team needs. But the hurdle to get started is probably a lot smaller than you think. Modern coding tools make this kind of tinkering more accessible than ever and a lot of fun. And if you want to start somewhere, please come find us after the talk. We are super happy to share more about our process and what we learned. Thank you.
Thank you.
Thank you so much, Frederick and Sam. That was amazing.
All right, y'all, now we're going to take a really quick break. If you're feeling a bit peckish, now's your chance to go grab a quick snack.
We will be back here at 12:30 in just a few minutes. See you back on the L2 stage.
Ciao.
Please welcome your hosts to the stage.
Hello, everyone. Welcome back to the L2 stage.
Hi, welcome back. It's great to have you. My name is Majola.
I'm Isaac.
And I hope you had I hope you had a chance to grab a snack, maybe a stretch, because we're going to get right back into it on the level stage. On the level 2 stage, sorry.
That's right. And our next talk, I'm so excited because we are about to learn how stagecraft informs product craft. Please give a warm welcome to Kim Beverett.
Let's do it.
Today, I'm going to give you a crash course in theater. And hopefully you're going to leave here feeling like there's very little difference between this and this. They both frame the audience's attention. Both say, focus here. Forget that world and enter this world. And within these two rounded rects are near limitless potential. My name is Kim Beverett. I am a product manager at OpenAI. I've been a founder. I was at Apple for 10 years. And I am authorized to give you this crash course on theater because I have a degree from the illustrious theatrical institution, Arizona State University. I've been an actor, a director, a stage manager, a costume designer, and obviously I wasn't exceptionally good at any of those things, otherwise I wouldn't be here giving you a talk today. But I was and still am obsessed with one thing: telling stories. People asked me how I moved from theatrical design to product design, and I tell them I never stopped designing for the theater. I just design for a different audience now. So let's kick off our crash course. This is a chair. Imagine you walk into a theater and you see this chair. What do you think about the show you're about to see? Probably that it's pretty standard, straightforward, not a lot of surprises. Now, you open an app, and the first screen looks like this. Remember, the user is your audience. What does that audience think? Probably this is a pretty standard, straightforward app. Not a lot of surprises. Now, you walk into this theater. What do you think? That's weird. What is that chair doing? Why is that chair there? That chair's over the side. What is that chair? Do you see that chair? Now, I, the audience member, I'm obsessed with that chair. And if you wanted me to be obsessed with that chair, congratulations, job well done. If you didn't, you now have a problem. Same thing here. What is that button doing? I'm obsessed with it, and it hurts me. This is the uncanny valley of choices. Now you walk into this theater. Now I'm excited. That is not normal chair behavior, but I know you did it on purpose because you wanted me to be interested and engaged from the moment I sat down. Same thing here. Weird choice. Clear choice. It's a choice that makes me pay attention and listen. It's a choice that a director would make because committing to choices is a director's primary job. There's a story from a director I love. Her name is Anne Bogart, and she tells this story about a young director in a really busy rehearsal. And an actor comes up and goes, where do I put this chair? And in her haste, the young director says, it doesn't matter. But in theater, as in software, we know that's wrong. Because to an audience, to the user, everything matters. When an audience member sits down in that seat, they assume that everything they're about to see was an intentional choice. It's tempting to look at this and see it as like a lack of choice, as some sort of representation of neutral, but it's not neutral. Within 5 seconds of entering this theater, I know the director chose to leave the curtain open, so I'm going to be thinking about what's about to happen. They used a plain kitchen chair, not a fancy chair, so I'm going to expect minimalism. They chose to light the center of the stage only, so I'm going to be a little uneasy, wondering what's happening outside the field of view. There is no neutral. Your audience is sophisticated. They feel the results of your choices, even if they couldn't explain why. The audience came to the theater not to see any show, They specifically came to see that director's choices, your choices. Everything is a choice. That's it, that's the first lesson. So be intentional with your choices because the audience assumes you were intentional with your choices. Okay, that was the first lesson. You ready for the advanced lesson? I'm about to show you several photos from one of the most groundbreaking shows of the 20th century. And we're gonna try to guess what show it is. I promise it's a show you've heard of. I also promise it's a little silly and you're allowed to laugh. Okay. We got a big old red feather. We got some tie-dye shirts in swings, trapezes, hammocks, guy on stilts, more tie-dye people running around. We got a trapeze and a big white box. Okay, I promised it was a show you've heard of. Anyone know what show this is? This is A Midsummer Night's Dream by the great Shakespeare himself, directed by Peter Brook at the Royal Shakespeare Company in 1970. And as we learned in our first theater lesson, good theater is made up of strong choices, and this show is a lot of strong choices. But first, a quick plot recap. Hermia loves Lysander, Helena loves Demetrius. Hermia is told to marry Demetrius instead. She says, hell no, runs to the forest with Lysander. Demetrius chases Hermia, Helena chases Demetrius. In the forest, there are fairies. They do fairy stuff. The fairy king gives them a love potion, so they love the wrong person. One guy gets turned into a donkey. They all wake up and laugh it off. Typical Shakespeare. But the staging and costumes here are anything but typical. At the time, A Midsummer Night's Dream was seen as mostly unserious. When people did stage it, they leaned into the magic and the fairies and the forest and the silliness, and it was a play for kids. If you want to see what that looked like, you don't have to go far for an example. This is A Midsummer Night's Dream, both of these. The exact same scene when the fairy king gives the love potion by the same theater company just 8 years previously. Again, same production, 8 years different, and you can see what a difference 8 years makes for a donkey costume. Also, fun fact, in the black and white, that's Judi Dench playing Titania. So, Peter Brook, our avant-garde director, he does not do theater like you see in this black and white picture. So why would he consent to do a show like Midsummer Night's Dream? Because he knew that the script is not the show. The show is the choices layered on top of the script. There's a reason Shakespeare is performed 1,000 times. We go back again and again because we want to see the interpretation, the perspective, the choices that a new director can bring. It's the same reason there's a cajillion to-do list apps. They've all got the same basic script, but we keep coming back because we're hoping for a new layer of choices that's actually going to help us return our library books. Brook wanted to put a very specific layer on top of his Midsummer Night's Dream. He wanted to go beyond illustration to evocation. He believed that evocation was more powerful than illustration, which frankly is a really bold choice. You're doing a show about magic and you don't want to illustrate it? No fairy wands, no sparkles, no glitter? No. Just a simple white box that lets you project your imagination onto it. Because the minute you put a real forest on stage, that's the minute the audience's imagination turns off. There's no need to work. There's a forest right there. In this picture, these wire balls, they represent bushes and foliage in the forest. Brook gave us nothing familiar to latch onto. He forces the audience at every turn to use their imagination because Brook believed evocation was greater than illustration, and that was the spine of his show. And the spine of a show is a crucial theatrical concept. A spine is a single overarching sentence to which every choice must adhere. Brook's spine was evocation over illustration. But if you were directing it, you could do something else, like the falsehood of choice or the ritualistic nature of humans. Or it's less important what the spine is and more so that it exists and that it resonates with the director and the cast and the crew. The spine is what allows diverse choices to tell the same story, what allows teams of radically different disciplines in the theater to function. Costumers, sound designers, actors. The director's primary job is to unite those choices under the spine of the show. We can see this in the set of Dream. This iconic white box, this is not credited to Brooke. It's credited to set and costume designer Sally Jacobs. This, by the way, is the actual model that she built with her hands to pitch this idea, because there was no Figma. Because Brooke set such a strong spine, Jacobs could make this crazy choice. This groundbreaking work didn't spring from the life of a single-minded genius man. Brooke admits that when he signed on for the production, he had a burning hunch that somewhere an unexpected form was waiting to be discovered. Which means he didn't have a plan. He had a script, a spine, and 10 weeks to figure it out, which, by the way, absolutely unheard of, 10 weeks. At the time, the Royal Shakespeare Company was giving productions 3 weeks to rehearse. But those 3 weeks, or 10 weeks, gave them the chance to experiment. They got to bring an audience in to watch rehearsals, and that audience informed their choices. You can see here Sally Jacobs' first drawings of the workmen, including the donkey, and what a journey they went on from the original drawing to the final production. Brooke knew that theater can only exist with the participation of an audience. A beautiful painting can exist without a viewer, but theater cannot. If good theater hinges on your choices, then you have to validate those choices as early as possible. The audience is not a passive viewer. They are a collaborator, a mirror, a witness. Brooke's Dream could not exist today because the audience from 1970 doesn't exist today. Because we've all seen a white box in abstract costumes a million times, and it doesn't trigger our imaginations in the same way. Entirely new choices would be required to support that same spine because we, the audience, the final members of the show, are different. This skeuomorphic choice made a lot of sense in 2009. Users were totally unfamiliar with a touchscreen and apps and all these paradigms, and they needed the hand-holding. Today, for us, not so much. This wacky 70s play with white walls and barbed wire bushes and trapeze magic changed the theatrical world. Without this play, we don't have Lion King or Hamilton or any of the theater we're accustomed to. And now to bring it back to software, I am blessed to work with a team that feels the same way as I do about software, even though they probably don't have any idea that I think of our features as little software plays. For example, we recently released a new feature into Codex. It's called computer use. It gives your computer a cursor and a keyboard so it can take action in your apps in the background. But we had to figure out how to represent that action taking to the user. We needed to show a cursor. So we could have just done this. Your computer already has a cursor. Just move that sucker from point A to point B and job done. That was the product requirement. That's what the script necessitated. But instead, we did this. We gave it a little glow and some personality and a little dance along the way. And this was hard. Our designer custom built this simulator to mock up all the potential paths the cursor could take. The engineer working on this spent days getting it right and lost sleep in some corner cases where the cursor didn't land just right. But why? Why spend all this extra effort? Because one choice says it doesn't matter, and one choice says everything matters. We've also got a team that loves to rehearse. We just released another feature called App Shots that lets you easily pull in context from your apps into Codex, and I can show you what it looks like today. So you just press Command, boop, and the context of your app, your screenshot and text is pulled into Codex so you can start working on it. But it took a year to get to this. I'm going to show you the journey. It's a little chaotic, but stick with me. First, at the top, we tried adding the user's apps to the chat bar. Didn't work. Then we tried magically inferring what app you wanted and letting you include it. Didn't work. Then we tried this lasso to connect them. Didn't work. But we got to the right solution with rehearsals, with working with our audience to find what actually made the task easy. Both of these features tell you a lot about the team that made them. The team that made these feels that computers are fun, that we are living in a time where software is producing near magic, but it rarely feels magical. I do not bring up these examples to say that my team is building the Midsummer Night's Dream of software, far from it. I just bring these up to say that even in the smallest of examples, you can make choices that help tell your story. So at this point, I hope that I've sold you on the value of choices. Easy, make some choices, right? Wrong. When I first previewed an early version of this talk to Anna, my exceedingly kind and patient handler for this config talk, she said, I think this is probably the most horrible and important piece of feedback I have ever received. Me, the person standing on stage, making a passionate plea for showing your choices in your work, and I wasn't doing it because I was scared. Not of showing a bunch of fancy designers avant-garde 70s theater, although that is terrifying. I was scared of sharing the real spine of this talk. I was scared because making these choices is scary on their own. Each choice closes a door, obliterates optionality. The violent act of choice is scary, but it's doubly scary when you're asked to make those choices based on your own perspective and lived experience, because that's what theater is. It's a brave plea for shared experience. You remove the costumes and remove the lights, and it's one person telling a story to another person. It's saying, here, this story is too big to hold inside my mind and my body. Will you help me hold it? It's taking the time to tell your story with purpose and care, such that every good show holds that warm echo of human intentionality. It's hard to think of something braver than that. But for years, we have layered rules on top of this brave act. You've probably heard of these. Aristotle was dictating how we tell stories in 335 BCE. He came up with this stack-ranked, yes, stack-ranked, list of 6 crucial elements of theater. What happens, who does it, how it sounds, and these rules still persist today. That last one, spectacle, that's like the wow of a show. That's just surprise and delight. Steve Jobs knew his classics. But I don't remember the stories that adhere strictly to those rules. I remember the stories that break them. What is maddening about our current moment is that we are building software like these rules are set in stone. We're using the most extraordinary technology that most of us have ever seen to create terribly ordinary work. Work that is the average of all of humanity's collective choices with the fingerprints removed and the edges filed off. This prompt is never going to produce something incredible. We cannot expect the averaging machine to produce anything other than averages. Can you imagine with me? A director walks into the first rehearsal. Make me a musical about Alexander Hamilton. Funny, with some rap. No. You want to see what that prompt made? Perfect. No notes. Now, there is nothing wrong with using these tools. Half of the images in this talk wouldn't exist without them. I am such a big fan of these tools that I tried really hard to have AI write this talk for me. And you know what it got me? It got me Anna saying that she felt like I wasn't bringing myself to my talk. Because try as I might, I could not get the tool to understand my unique human experience. I guess there just wasn't enough costume designer turned product manager in the data set. The spine had to come from me. Brooks' Dream premiered in 1970, and it caused a ripple in the theater that we still feel today. But in 1969, no one saw it coming. And right now, we are in a 1969 moment. We are on the eve of a software and design revolution that will ripple out for generations. A radical new form of software is coming, and we are not going to get there with this. We are going to get there when we make choices that show who we are, when our choices show that warm echo of human intentionality. That is going to dictate the new forms we discover. Brooke himself was aware of this need for change. The great tragedy of his Midsummer Night's Dream is that it was never properly filmed. And when asked why, he said this: "No form nor interpretation is forever. A form has to become fixed for a short time, then it has to go. As the world changes, there will and must be new and totally unpredictable dreams. It's time for new dreams, new forms, and I cannot wait to see what dreams you create." Thank you.
Wow, thank you so much, Kim. That was really inspiring. And honestly, if the software engineering thing doesn't work out for me, maybe I'll try my luck on Broadway.
Speaking of software engineering, pop quiz designers, define operating system. I'm just kidding. You've heard of Windows, you've heard of Mac, but these Figmates are about to introduce you to PMOS. Please, give it up for Lawrence and Janen.
What's up, Config? How you doing? My name is Janen, and I'm a product lead for Slides and FigJam.
And hey, I'm Lawrence, and I'm a TPM on the product team at Figma. And we're so excited to be here today to share the story of how we built a tool we call PMOS for our team. So the seed for this initiative was planted a few months ago by Ezra, a PM on our monetization team. He was exploring the limits of the AI tools that we had access to at the time. And as a sort of passion project, he wrote this very compelling exploration into a day in the life of a fully AI-enabled PM, which I thought was incredibly aspirational when I first saw it. That's because, for starters, the landscape of a PM is incredibly messy. A major pain point that we often deal with is juggling context across a bunch of different tools. You have questions and feedback coming in on Slack. You have write-ups in your docs. You're doing brainstorms and bug bashes in FigJam. There's your designs, and you're doing design crits in Figma, not to mention all of the task trackers and the spreadsheets that you've got to keep updated. And so as a result, you're constantly looking across 5 or 6 different tools at all these different notifications. And it's such a headache for anyone who's just trying to get context and caught up. And although we understood theoretically that AI was going to help us with this, in practice, the tools weren't really talking to each other, and Ezra pointed out that it was actually feeling more complex than not. Another way to look at the problem is where PM's time actually goes day to day. And so if you're a PM, or if you work with one, you might see that this is what their calendar looks like. And since so much of our work happens in Slack or async, it's very common for people at Figma, on the PM specifically, to start their day with a focus block where all they do is catch up on Slack notifications or look at all these different tools. And if you're on a global team like us, it's also very common to wake up and already feel like you're behind. Then during the workday, you have a whole bunch of meetings. You need some time to prep for or to debrief from these meetings. And you don't really have that much time to do focused work. A lot of times that gets pushed towards the end of the day or in the evening, or you just don't even get to it at all. And that's sort of the nature of glue work that just eats up your time. But what if it didn't have to? What if AI took care of all of that busy work for us? If PMs were freed from the glue work, their time could instead go towards meaningful strategy and craft work that PMs were uniquely equipped to do. And with AI helping us still run effective meetings, update documentation, and send updates to the right channels, then PMs just fully focus on higher leverage opportunities. So Ezra's proposal was super inspiring, but proposals alone don't change anything either. You need someone to do the work. Or in some cases, you need your manager to tell you to do the work. And so that's where Yuki, our chief product officer, came in. He saw the momentum around this write-up, and he called on 3 volunteers, Ezra, Janen, and myself, who were showing the most interest in the problem. And he asked us to work together to bring this vision to life. And no challenge is complete without a time limit, and so he gave us 1 month to build the thing and roll it out to the entire team, to which we said challenge accepted. But before we run away and get ahead of ourselves, we didn't want to rush and end up building the wrong thing. I really love this meme about the duality of working with AI, because if you do it wrong, you feel like you have to use AI at work. But if you get it right, you feel like you get to use AI at work, and it's actually adding value. And so it was very important to us to make sure that we landed on the good side and built for the happy path. And that's why even though all of our customers are internal, we still started out with a few principles. And these were inspired by the product teams who are working on the launches that you saw earlier today, but applied for ourselves. So first off, we wanted to start off with a very simple use case. It's tempting when you're starting with this really grand vision or like a North Star document to try to design the whole system at once, but we thought that would be biting off more than we could chew. So we tried to focus on a single use case and let the complexity grow from there. Second, we wanted to take it one step further than building with users in mind. We wanted to actually build with our users, and for us, that means our team. And that meant frequently checking in with, working with the PMs at Figma, and making sure that what we built was feeling really useful to them. And finally, the way to make something worth using every day is first to try using it every day yourself. And so this was a core requirement as we got going, that we were trying to find product market fit for ourselves with our personal workflows before considering the rest of the teams. And that way we were confident that eventually we could brand this the PM OS, and that we would feel like we had built it for us by us. And so putting that together, we decided to narrow down to that single use case to start from. And as I mentioned earlier, a lot of PMs are starting their day reading Slack, reading a bunch of notifications, opening a bunch of different tools, and we wondered if we could turn that very tedious and fragmented ritual into something that was as simple as reading an article in a newspaper. And the way that would actually work is with a simple interaction where you can ask an AI, "What's up?" And it would tell you everything that you needed to know, what was new about your work streams, and nothing unnecessary besides that. But as it turns out, making that work exactly the way we wanted it to is a lot easier said than done. And Janen's going to tell you about that journey.
Thanks, Lawrence. Yes, so this felt simple enough. And so we decided the best way to learn if we could do it was just to try to build it straight away. And we started the way that most people do these days. We wrote a simple prompt to see if AI could just one-shot a perfect what's up. So we wrote search Slack, Asana, and FigJam, and summarized the most important updates in the last 24 hours. Make no mistakes. We put that simple prompt in a skills file so we could run it on demand, and we took a look at the output. But unfortunately, it wasn't very good, not very surprisingly. Even though the agent had connections to all of these different services, its ability to understand what matters to me was understandably quite poor. And so then I tweaked it. I specified the channels that mattered the most. I included more context about who I work with, like my manager, my teammates. And this instantly improved what was included in the update. However, it was still really verbose. It didn't include sources, so I couldn't click through to learn more. And in general, it just didn't feel great to use. And so then we added more instructions. Here I said, use a maximum of 5 bullets, always include sources, prioritize the items that seem like they're action items for me. And essentially, we felt really good about where this headed, but we knew it wouldn't really abstract really well to other skills. And we realized that there were 3 fundamental building blocks to making any skill for this type of project really valuable. Those are context, profile, and experience. Context is ensuring that the agent not only can access different important services and artifacts, but also that it knows what matters the most. Profile ensures that the agent understands who you work with, what matters to you, your priorities. And the experience is about making the output readable, useful, even beautiful. And so we took those building blocks and we abstracted them into their own files so that any prompt or skill could access them. So now, for example, if I ask it to search Asana, it does a great job because it knows exactly what projects I belong to and what my priorities are. It also understands phrases like my organization because it knows what part of the org I belong to. Most importantly, we realized that almost all of our ideas to streamline or automate work would benefit from these building blocks. So all of our other ideas for skills would become a lot easier. And it was at that point that we decided to put a home for all these skills and these building blocks into GitHub. And that's when we felt like we arrived at an early version of PMOS. So after a while of riffing on it as a small working group, we wanted to roll it out to more people. And we had a realization that the best way to do that would be to have some default apps or starter skills. And so we thought that there were 3 really great use cases to start. The first was, of course, What's Up, which we've already talked about. So this helps you make sense of all the services you need to stay glued to as a PM. It finds all of the signal in the noise. The second, this one's one of my favorites, which is to write your weekly update. So if you say, write my weekly update, it'll actually not just give you information, but it'll actually write your update based on your GitHub contributions, what you're doing on Slack, what you've done in Asana. It will even write it in your voice, and it will include what shipped, what's coming next, what's top of mind. And then there's one click to publish it. And then the third one was a spec reviewer. So at Figma, we have a very specific process and template for writing specs. This includes sections like problem, solution, metrics, etc. And with the spec reviewer, it'll give you a report card on how well completed those sections are. Anything that's yellow or red, it will actually coach you and help elevate the standard of your document. One of the cool things about this, though, about this journey, is that even without specific custom skills, we realized that PMOS could use these building blocks to just answer any question that was useful. So in this case, if I ask who worked on the FigJam MCP, it'll actually take a look at GitHub and our org chart and pinpoint exactly who contributed. OK, so we had the OS framework, we had the starter apps, we started to feel pretty good about it, and then we needed more people in the product org to try it. And there were kind of 2 steps to make this possible. The first is you have to become a forward deployed engineer at your own company. So what does that actually mean? It means you need to actually set up time with your teammates, sit with them, and watch them onboard into your product. And that's exactly what we did for PMOS. Initially, people will get stuck on step 1, but over time, we sort of smoothed out the rough edges by keeping a friction log of every problem, every complaint, anything that was confusing, and then stack ranking them and addressing them. And we did this loop in a really fast way. And so we did this over 10 times with our team. Eventually, we ended up with an all-new setup experience, new help documentation, and more. And it was at that point that we decided to share with the product team that we were ready for them to try PMOS. So we went from just the working group onboarded to about 25% of the product team set up. This was very exciting. However, we kind of hit a ceiling at this point, and we wondered why. So we spoke to the people who didn't onboard, and we heard the same thing over and over, which is just that they needed dedicated time, dedicated attention to set up. And so even though we made it as simple as possible from our POV, we knew that we weren't going to be able to get people to do this in between their busy day, in between their meetings. And so that led to step 2 of rolling out a new AI native way of working, and that's to hijack an offsite, or really any virtual or physical space where you have your team's attention. Lucky for us, we had a product team offsite, and we became a formal part of the programming. And so we not only wanted to onboard people into PMOS, but we actually wanted to help them learn how to build and extend PMOS so it really felt like their own. And so with that goal, we actually ran a hackathon, and people used PMOS to build on top of PMOS, which was very gratifying and really cool. And by the end of it, dozens of improvements actually shipped, committed to GitHub. People improved the building blocks, they improved existing skills, they added new ones. And there were fun ones too. So one of them was to automatically make a FigJam board when it's someone's work anniversary. Another one could take a spec and turn it into a pitch deck. And there were dozens. It was great. So at that point, we had 100% adoption of the product org. We received lots of positive feedback, which we're really proud of. My favorite one is the one here in blue from Pratik. He was actually out on paternity leave during the development of PMOS, including the offsite. And when he returned, he set up on his own. But more importantly, he actually said that he feels not only caught up, but that he feels like there's this new way of doing work as a PM thanks to this tool.
Awesome. So yeah, at this point, everything was really coming together. If there's any younger Gen Z in the audience, this is a reference to Windows XP. It's an older operating system. It's the one that I grew up on. And we really like the analogy to an operating system as both our namesake as well for PMOS, because there's apps that come with it, there's more that you can install, and you can also be a developer and build your own. And we've sort of seen this developer ecosystem pop up around PMOS within Figma, where people are adding skills, upgrading the existing ones, even changing the look and feel. We've even had some brave people fork the whole thing. Shout out to Prasant, a PM on the editor team, he might be in here, who's been one of our most prolific contributors. And I was talking to PMs as part of preparing for this talk to see how they were using it, if it was part of their day-to-day workflows. And I was really blown away by how much people seem to already trust and rely on this tool. And to give you an example of what that might look like, let's step into the shoes of Elin, one of our growth PMs, and let's say that she needs to make this decision for a new user experience if we're going to show a welcome screen or a template gallery. And so she'll now go to PMOS and just have a conversation with it, like a thought partner. And because PMOS knows our operating manual, or like our internal wiki of how we work, it can suggest that she should do a product review. And it can offer to go and gather some of the context and even scaffold the content for a FigJam board that she can use during this review. And so it'll first go out onto searching Slack using the Scout skill and follow links all on its own, and in this way, kind of get a picture of what opinions are currently in play. Then it notices that there's an ongoing experiment, so it can invoke the experiment review skill, which uses the Hex MCP, will pull some real results and put quantifiable evidence into the picture. And then Elin knows that some of her stakeholders might care about technical trade-offs in particular, so she can ask it to use the Codebase Insights skill, which will use the GitHub connector to look at the actual codebase and then help provide an informed opinion on some of the trade-offs pertaining to the implementation architecture. And of course, engineers can and should verify that. Finally, with the help of the FigJam Builder skill, using the Figma MCP, PMOS and Elin combine to design a clearly laid out agenda in FigJam, bringing together all of these considerations, layering in her point of view, and enabling a really productive discussion. And so the best part of this is, Elin didn't have to dig through a whole bunch of Slack channels herself. She didn't have to write any SQL. She barely had to bug the engineers. And she didn't even have to fiddle with the size or the color of sections on a FigJam board. All she needed was to know the decision that she wanted to make, the inputs that stakeholders care about, and how she wanted to frame up the conversation. And then she let PMOS just handle the rest. And in doing so, she probably saved at least 2 hours of her own time. And the prep still culminates in the most important part of product development that AI is not going to replace, which is the side-by-side discussion, the riffing, and the debate between real people, which is how consequential decisions still have to be made. And so when I heard Elin and other PMs describing these workflows to me, I felt like we'd reached this full circle moment from Ezra's manifesto just a few short months ago. And looking back, we've actually unlocked just about all of the tooling that we used to speculate about. Of course, in the grand scheme of things, we think we're still pretty early in terms of unlocking the full potential of the team. But what I hope you take away from this talk isn't that we've actually built anything particularly revolutionary or unique in any way. Because what we did with Figma's PM team with PMOS, you could just as easily do for yours with a PMOS or a design OS or a company OS. Everyone here is figuring out how to work with AI at the same time. And the technology is so nascent that I don't think there's a skill gap or a skill issue at all. Still, I think there are a few key ingredients that were crucial to the success of PMOS at Figma. First, we started with a few passionate individuals. We were given clear sponsorship and a timeline. And this is a situation where these constraints can breed creativity. In larger organizations, sometimes you actually do need permission to run on a big new idea, and that happens to be how we got started.
Yeah, and on top of that, we followed our own rules. We started simple. We built something that we thought would be genuinely useful for ourselves. And we talked to every single user along the way, from a single skill to the full-blown project of PMOS.
And what we landed on was this system that combines your profile, your organization's context, and a thoughtful user experience all in by default. And once we put together these building blocks, it created something that felt greater than the sum of its parts.
And so that's what's up with PMOS. Wherever you are in your journey with implementing AI in your company, whether it's a single skill or a really large, complex project, we'd love to hear what you're up to as well.
Thank you.
Thank you.
Wow, great job, Lawrence and Janan. That talk was so good you'd have Steve Ballmer screaming, PMs, PMs, PM.
We're now going to take a break, so feel free to stretch out, grab a bite, make some friends.
We'll see you back here at 2:15.
Please welcome back your hosts.
Hello, everyone, and welcome back to the L2 stage. I hope you're all feeling refreshed and ready for some more amazing talks. My name is Isaac.
And my name is Majola. And next up, we have the founder of EDL, who is transforming how you work with code or work with designs in your code repos. Hey, Isaac, knock, knock.
Who's there?
Git.
Git who?
Get ready and join me in welcoming Frederick Anderson to the stage.
Thank you. Hello, everybody. Hi, super excited to be here. I've been asked to talk about my personal experience of turning my design studio into a design engineering studio that ships and owns design systems in code. I haven't flown across the Atlantic Ocean to come here to talk about AI, even though these slides may make it seem like it. Between you and I, I'm kind of sick of AI, honestly, and just the Uber ride here from the airport, like watching all those billboards, that's insane. However, the technology, AI as a tool, is a catalyst for us as designers, for our industry, and for my studio too, to move upstream, to take more ownership of things. My name is Frederick. I run a 9-person design studio back in Copenhagen. Most of our design team push to client repos today. I haven't forced anybody to do this, by the way. I've created the opportunity for them to move in that direction. However, as you all know, the work we've been doing for a while now has kind of been moving in that direction, even before AI. From a business POV, as a design studio, there's a huge commercial upside for us to own design system work and move closer to code as designer. But I took this risk, I moved in this direction because of more personal reasons. And I'll start with that first. 12 years. That's how long I've watched really careful design work get butchered in implementation. And that just sounds a bit rough. My coworkers or my own design work, not by bad developers, not by ill intentions, but by a gap I'd accepted as just normal, cost of doing business. We'd spent months getting something right, and it would ship looking just, a bit wrong. I called it a communication issue. I called it a Figma annotation issue, but it wasn't. It was a structural issue. And what I've come to realize, at least, is that the person who cares about the detail is not the person who implements said details. 8 months into, just to give you a bit of behind the scenes of my studio, 8 months into most client relationship, the hardest work for us was sort of done. Like we'd architected the systems, we'd redesigned their products. After that, we were just sort of on the outside looking in. We'd see certain things get pulled apart. It wasn't the engineer's fault on their own, and we weren't there to govern it. Decisions were made in isolation. Stakeholders give feedback way too late sometimes, but that's where I saw the opportunity. I saw the opportunity that if my designers could gain the trust of our clients to get access to our clients' code base, we could own the design system. We could quality assure things. We could take ownership of component decisions. We'd be able to keep the integrity of our design work, essentially. The relationship would also be stronger because we would all of a sudden be able to take ownership of quality, the output of what we care so much about, what ends up in the user's hands. And engineers, from my perspective at least, would be freed up to do way more important stuff, innovative stuff. That's a win-win-win situation. And in case you were wondering, yes, every quarter for the last 5 years of having this agency, this studio, I've been thinking about hiring my own developers in-house. I haven't done that, though. They would have the same taste as us. They would be sitting next to the designers who made the decisions. We would have control of the output. Agencies I've looked up to for decades, Fantasy, MetaLab, Ueno, great teams have done it this way with great success. But I also knew what would happen next. The engineering headcount would probably start to grow a bit, usually by demand. Then it would outgrow the design team that I originally set out to build. And suddenly I'm running a development agency with a design function attached. And for me, personally, that simply wasn't what I wanted to do. AI, as a tool, changed that. Not because it makes coding easier, although it obviously does, we all know this, but because it changed the timeline. Now stick with me here, because This comes from my own mind. 2 years ago, a product designer shipping production code or maintaining a design system, that would be a career change, completely. Like back to school, courses, late night learning. Now, it means 2 to 4 months of just focused work under the right conditions, and the conditions are super crucial. I'll get back to this. I'm not interested. I don't know how many engineers is in this audience, but I'm not interested in getting jumped by them after this talk. So I just want to clarify that AI have not made anybody, a design engineer or a design system architect like from day one. It requires exposure, extensive training. That's what we've been going through. Like you need architectural instinct. You need the DOM understanding. You need to be able to direct the tool and not be directed by it. Prompt engineering, super important. AI sped up the timeline. It did not move any bars, for quality. Regardless, the opportunity enabled us as a design studio to essentially stop handoffs. We started building, we started shipping. We stopped being a vendor that simply delivers, and we became what engineers build on top of. That's crazy. That's still crazy to me. So if you're unaware that this is a possibility, even after today, after all these great talks we had, I'm here to tell you that it's not. It's right now. And it starts with design system ownership in code. We as designers can have a much larger integral impact on important product features if we own the design system. We're all in different situations, both in here and online. So I'm here to show you how a small Copenhagen-based design studio did it, but whether you're a Fortune 500 design director or a chief design officer, freelancer even, this playbook remains the same. And it starts with one designer and the right conditions. The key is picking one person, not a team, not your entire organization, one person. And for me, that was Modestus. He's in the crowd somewhere here, so you should find him and talk to him later. To give you some context, over there, I hired him 3 years earlier to replace me in Figma. I had to run a studio. 3 reasons why I picked him. He was organized, detail-obsessed, and curious about code. All wonderful traits to find in a designer. But personality wasn't enough, unfortunately. He also had 4 slightly underdeveloped skills, capabilities that I needed for this to work. Or so I thought. He thought architecturally, a component lived inside a system in his head, not on a page in Figma, not on the canvas. He thought about how his work would be consumed downstream by developers. We saw that in, nice Figma files, good handoffs. Developers actually wanted to consume his work. He had basic DOM understanding from working with developers previously, and like anybody in this room, he could learn how to prompt. Not type into a chat box prompt, but direct a tool prompt. There's a big, big distinction here. A quick note on perfectionism, because I know a lot of people in this room probably have it. This will speed up the learning process, big time, but you need to manage it. Modestus was and still is super defensive about his ideas. He's super proud. He wants to impress. He's a good old-fashioned perfectionist. I love that about him because I'm very similar. But as a leader, those traits are important to notice because you need to design around them. Good traits can pose as negatives, when you're moving people to a different place or changing their career essentially from design to engineering. I expected this perfectionism would slow him down because I knew for myself that would paralyze me if I all of a sudden had to, go from a Figma canvas to make design system architectural decision that would last a long time in code. Early on, I did not need polish. I just needed momentum. That's why I told Modestus early on that I expect mistakes. I expect us to look back on this work in the next upcoming weeks and, be embarrassed by it. That's the signal that what we're doing here is working. Imposter syndrome is very prevalent among me, you, all of us. If you sprinkle a bit of design system architecture on top of that, you have a lethal mixture. So you, as a leader, need to name it before they do. Modestus was down for a challenge. So before we moved on, I time-boxed 1 week. This seems simple, but it was really good. I removed everything from his calendar, gave him 1 week. I handed him a B2B SaaS UI. I know you guys love this over here. B2B SaaS UI that we had designed in Figma. It was fully spec'd. It was ready to go. Never shipped, never coded. It was just staying in Figma. I had some expectations. They were quite simple. I wanted him to extract the components. I wanted him to build the initial storybook setup. I wanted him to make it real. Mind you, he'd never built a production component library before, and I wasn't testing whether he could do that cleanly. That would be foolish at this point. I was testing whether he could, under the circumstances, under a bit of time pressure, being uncomfortable, lift those capabilities, those 4 capabilities I just mentioned before. This is what we had at the end of the week. Storybook running, components separated, working in a browser, not in a Figma file. That was a big step. He read his way into, half of it and, messed around and figured things out as he went along. Some of it was rough, some of it was over-engineered, none of it was finished by any means. But the 4 capabilities I was looking for was all in there. That was enough for me to fully commit. We moved on to something a bit more fun, which was billable work after this. But before I mention that, I got to share you how certain things needed to line up before we made that decision. The studio absorbed the cost of him learning on the job, obviously. He's got to be able to go at his own pace. It's super important. You cannot rush this stuff. We bought a design system course to strengthen architectural decisions and get some terminology going both internally and externally. And as corny as this may sound, trust was a huge part of this. He started prototyping his design in code on his own without my mandate because he thought that was a better medium to express his design work. That's trust. I had a very quick, clear aha moment shortly after the initial test. Modestus has designed something in Figma. I think it was a complex chart component, and we were told it was unbuildable. This is not possible. Modestus asked what kind of JavaScript framework the developers were using. He coded it in Cursor, prototyped it, and he walked the developers through his implementation. Turns out it wasn't that unbuildable after all. And that was like, okay, this is the right thing for us to do. Truly one of the most important things I did, and also one of the simplest. I dedicated 15 minutes of my own time every day. I called it a design engineering sync. It was 2 p.m., and it was a daily deadline, essentially. Individual contributors, from my experience, can, without a clear horizon, can disappear into problems and, perfectionism. And the sync gave us a reason to surface, to talk. Sometimes we talk for 5 minutes, sometimes we talk for hours. Doesn't matter, but it was there. Then, I put him in engineering meetings. This was the scariest room I could think of, representing engineering meetings at that point in time. Great movie, too. In the start, the meetings was uncomfortable for both of us because it was all brand new. We had architecture talks, we had planning sessions, rooms where we did not have all the answers yet. The instinct most leaders have here is to protect, smooth the path, which is a good instinct, and I agree with that. But initially here, the only thing I protected Modestus from was one thing, and that was being publicly exposed by engineers in these meetings before he had the language to hold his own. There's a sentence I used in these rooms. We'll circle back to you on that. We need to weigh our options. That's a complete answer. Requires no apology, shows process, not ignorance, and you really cannot be ignorant when you're moving from design to engineering. You need to find your version of this because it will happen. Modestus watched me use this sentence initially. He started using it himself, and at this point, he doesn't need it anymore. This goes without saying, but for all my leaders in this room, in such a drastic transformation that is moving a designer to become more engineering-led, there's a difference between protecting them from shame and protecting them from struggle. Struggle is a good thing. Struggle is how we all grow. Contemplating how, we made the wrong architectural decision 2 weeks too late, that sucks, but it's growth. The late nights reading Reddit threads about what Angular framework to use for your next cross-platform mobile application, I'm sure that sucks, but it's growth, and it's really good. Shame, however, is how people stop growing. Looking stupid in a Zoom call full of engineers. Kills any momentum, kills any growth you've grown with this person. You gotta intervene on the shame, and you gotta stay out of the struggle. The struggle is good. Back to the timeline. By October, we shipped our first design system with downstream developers consuming our work. In code. Big deal. It was the initial building blocks, the foundation, the semantic tokens, the primitive components, all this jazz. We even built a feature using our own NPM package. That's crazy. Our own NPM package. It was an invoicing module, fake logic, but it was their developers, PropMiner, our clients' developers, would hook it up to their own API, separation of concerns, just how we wanted it. It was really good, and it created the goodwill we needed as a design studio to be able to take more ownership of engineering. Later, same year, in December, we had to extend, restructure slightly the storybook we built because ProcMiner wanted us to make a mobile application for them. Shows what we were doing was working. That foundation, those mobile components, all those architectural choices now runs a handful of white label apps in production. Built off the work one designer did in his first 5 months of transitioning into a design engineering role. A designer built this. And at this point, many designers have built this, actually. Super, super exciting. At this point, I started seeing things at the office. Culturally, things were happening. I first saw it in our Friday design reviews. The whole studio looks at work in progress together. Modestas had already started bringing his components, his code, his storybook to these design review meetings. He brought code. And we started to see the why and what we were doing clicking in the eyes of everybody in the studio. Design engineering and design system work started to become a topic in our personal development conversations. First time it happened, a designer asked me in our one-on-one, hey, Frederick, I want to do what Modestas is doing. How can we make this happen? At this point, Modestas had already done the hard part of showing everybody that you as a designer can transition into something potentially, for them, more meaningful. You could take more ownership of things. The empowerment was flowing through our team. And to capitalize on this, I planned for Modestas to speak to his colleagues. We were heading on our annual retreat in October anyway at this point, so it was perfect timing. Not only did I communicate on this annual retreat that, us as a design studio in the next year would be, our core services would become design engineering and design system ownership, which just sounds insane. But I also asked Modestas to present. It wasn't a status update, it was a real talk about what design engineering is and what it unlocks for a designer, for our industry. He stood in front of his colleagues who had watched him be uncomfortable and, very deep in his work for months, and he shared his optimism that this is the future. This is the future for us as designers. For me, and this seems obvious, but for me, the same talk would have been an instruction. But from Modestas, a guy people trusted, it was an offer. Believe it or not, people don't move passionately in any direction, especially not a career change, just because their boss tells them that this new thing over here, AI, is great. They move when somebody they trust, like Modestas, shows them what is possible. This is also important to say, because the honest version is that not everybody in my team have asked to do this transition. Some are juniors who want to deepen their product design craft, and that comes first. That's super important. Some people are still cautious about this whole thing, and I get that. But Modestas is part of, when they get there, they get there. Half of my designers ship code today. The other half does equally important work. The future of our industry, does not require everybody to transition into this. Not at all. 12 months ago, Modestas was, quote-unquote, only making pixels in Figma. Really good pixels. But today, the design systems he built is consumed by developers across 3 continents. That's not a job change. That's a completely different person doing completely different work in a very short amount of time. And as a leader, watching this happen has been one of the most rewarding things that I've done in the 5 years of running the studio. And I truly believe that you get to experience that too. Quickly, here's how it looks. Just a screenshot from a Git repository. 3 designers from a team pushing stuff into our client's code base. This seemed impossible and insane not that long ago. And this number still surprising me. We had to double check this a few times before we flew over here. 84% of production code in one of our clients' projects is built by designer. We have a design system component coverage that is sky high. We have that ownership. We have that quality. For most of the code base that we're in, and the one I just mentioned, the line between designer and engineer isn't just blurred, it's completely removed. And that's design engineering to me. That makes me so excited. I run a small studio, no scale, no famous name. Outcome is what I sell, what actually ships, what actually moves our client's business forward. Design engineering is what let me build the studio I always dreamed of in terms of craft. One where the gap between what we intended as designers in Figma and what ships is as small as we can possibly make it. The commercial upside is real. But that's not why I made the bet. I took the risk because the work I wanted to make as a design studio simply wasn't possible any other way. And I'm here to tell you that design needs to own the code. Whether that's your organization's design system or the front-end implementation of an integral part of your product experience, you guys need to own the code. Design needs to move upstream. If you lead a design team, I'll leave you with this. If you lead a design team, next Monday, pick the designer who cares and who shares similar capabilities and interests as Modestus. Hand them a UI ready for implementation. Give them a week to build it. Get out of their way. Don't force your entire organization to chase this shiny new thing over here. It will backfire. And if you're a designer in this room thinking, my leader will never move on this, I won't get the opportunity, you've got to start anyway. The skills that you build now will compound, like from a decade from now. This is the thing you need to focus on. Monday, set up your LLM of your choice. Get started with Figma MCP. Ask a developer you trust in your team for access to their code base. Fix something small, build something new you just designed in Figma. Ideally using the components from your storybook or component library. Your developers will love you for that. Be curious. Ask why. The skills that you acquire now will compound. You don't need permission to start. Finally, for the leaders in this room, I've written down some thoughts in a more extended version than I can present in 20 minutes. The day-to-day, the decision-making, the commercial impact. You can download it here or find me and my team roaming around for the rest of the week. We'd love to chat, share you a link. Thank you very much.
Thank you, Frederick. That was amazing. It's crazy how much faster you can go when design and code work seamlessly together.
We are flying through these talks, and you know who else is moving fast?
Ooh.
Jenny and Mike at Epsilon. They're going to be sharing how they're moving from design to production faster than ever. Please give a warm welcome to Jenny and Mike.
Hey, Config, how's your day going? Okay, good, awesome. All right, quick show of hands. How many of you in the last year or so have used AI to generate a UI mockup with your design system, only to spend twice as much time fixing all the broken spacing and design tokens? Yep.
Exactly. We see those hands. AI gives us incredible speed, but it usually leaves us with a massive cleanup job. Hi, I'm Jenny. I'm the lead of the UX/QA engineering team at Epsilon.
And I'm Mike, UI design lead. Today, we want to discuss how we've applied a new way of thinking to our production process to eliminate those generative design issues.
Let's start from my angle. Traditionally, teams treat QA as the gatekeeper right before a product launch. The final hurdle that slows everything down. Well, as a small team against over 20 products designers and a dozen of products engineering teams, we were already outnumbered 100 to 1. And we're overseeing the UI governance of more than 60 complex applications like audience builder, campaign management, and loyalty programs. And these are only a few examples across the entire Epsilon portfolio.
Right. When you combine a fragmented workflow, BRD to Figma, Code to Figma, and various AI tools that you're using on a daily basis across a massive portfolio of our size, the traditional gatekeeper model simply stops working. Historically, if you have a design system, you're built to move fast. But like many of you out there, our design to dev handoff was becoming a place where speed went to the graveyard. So let's take a look at our design system. At Epsilon, we rely on Core UI design system to keep everything unified. But look at the sheer scale of what we have to manually govern. We're talking about 50 plus components, over 30 subcomponents, 200 plus style tokens, and more than 100 strict rules and patterns.
And if you multiply those numbers, there are 4 billion possible combinations. That means there are 4 billion ways for something to go wrong. And at that scale, checking every single detail manually doesn't just get harder, it becomes impossible. And when manual QA fails, the entire product's pipeline breaks down with it.
Right, and yeah, if we can, yeah, there we go. A little slide issue there. And then the notes are still off a little bit. Yeah, oh, nope, they're right. So the breakdown of this is the breakdown we like to call the pendulum of failure. On one side, you have paralysis from overgovernance. If we try to check every rule by hand and micromanage every pixel, the workflow slows to a halt, innovation fades, and the handoff turns into friction.
And on the other side, you have chaos that's under governance. When rules aren't enforced consistently, the system starts to drift in subtle ways. Small inconsistencies begin to stack. You know what those are. Spacing feels off, components behave differently, and edge cases are missed. And the developers are forced to make judgment calls, and designers, they lose confidence in what's being built. So over time, the experience fragments. It's not one huge failure, but 1,000 tiny ones that slowly pull the product out of alignment.
Right, and with these swings of misalignment, we didn't want to have to choose between speed or control. What we really wanted to choose was an equilibrium, a system where we can move fast without losing any precision.
So, we have completely reinvented our process. Today, we are going to show you a simple but massive shift, moving QA to the very front of the workflow. We're going to show you how you can design at lightning speed without sacrificing precision. We'll show you also how we train our agents to automatically enforce rules so that you can stop playing the design police and get back to doing what you do best.
Absolutely, and that's when we realized something fundamental. The problem wasn't that our AI wasn't powerful enough. It wasn't even a tooling issue. We didn't even need smarter AI. We needed an AI that could audit itself. We needed metacognition. If you've never heard of metacognition, it's simply thinking about thinking. It's the ability to reflect on a mistake, diagnose it, and rewrite the rules to prevent it from happening again. Jenny, let's go ahead and show them what this architecture actually looks like.
Of course, Mike, this is our meta-cognitive design loop. Ingest, plan, build. You're all very familiar with these steps. Standard AI stops at step 3. And it builds and then it throws the outputs across the fence for us to fix. We have eliminated that by building step 4 and 5. Our AI checks against the core UI its own work, and then it loops automatically until it passes every single rule.
And finally, step 6 solidifies those new rules. Every correction triggers a Git commit that makes our process smarter and more reliable after each use, creating our desired equilibrium.
We aren't just generating UI, we are building a shared QA mind. So how do we actually train this mind? How do we talk to it?
Well, we didn't want to compromise. We wanted to cure that pendulum of failure. So we built the workflow on 2 foundational tools. The first is the Core UI MCP. It gives us direct access to our Figma Live tokens, so no approximation, no assumptions. It builds strictly and pulls from the latest component catalog of Core UI, runs every rule it's ever learned, and self-corrects repeatedly before a human ever sees the first output.
And within this MCP, we have built a dedicated UX QA tool. This is where proactive architecture protects the system's integrity. Every review is grounded within the embedded Core UI knowledge base, so the AI never drifts from the source of truth.
And second is the second tool is the BRD agent, the business requirements document agent. Think of it this way. Core UI MCP protects the code. The BRD agent protects the strategy. And the strategy needs to be locked in early because, as we all know, the worst moment to discover what you're actually building is wrong is when the design and the development work has already begun. And this is where UX iteration has its biggest impact. Of course, AI accelerates growth, it accelerates exploration, but it doesn't replace the rigor. Our team still needs to iterate, verify, and test against concrete requirements. We're not prompting, walking away, and calling it done. We've built a workflow that ensures UX design has the time and scrutiny it deserves before anything reaches handoff, allowing them to have greater understanding of proposed features and business requirements. So, let's see how this agent actually encodes those details.
This is how our BRD agent workflow operates. We break it down into 3 simple steps. We needed to switch.
Yeah, the slides are just not working today. There it goes.
So we've broken down into very simple steps. First is setup. Instead of starting from a blank document, the agent interviews the PO very structured and focused questions like who the new users are for these features and what exactly is out of scope. And if the PO already has a draft, they can upload it as well. Second is generation. Once the agent has gathered all of the information, it assembles a plan. It translates plain English into exact core UI components. And when it's not able to find a perfect match between a component and a feature, it carefully flags them as concept slots on the coded prototype or on the Figma file so that our designers can review them at a later time. And finally is review and approve. This is where human in the loop takes place. Once the PO has explicitly approved the plan, now this business requirements document is ready for prototyping handoff so that our designers can iterate on them. This simple process ensures that every input is on brand, accurate, and consistent.
Yeah, and to support our new process, we use Figma's Code Connect to make our MCP and agent workflow sharper. But building those Code Connect files actually revealed something. Our coded library and our design files were not speaking the same language. So let's take a look at an example up here. In our coded library, this component is called the 2-tier site header. But in our Figma library and in our Storybook demo, it's called the double-tier site header. Same component, but 2 different names. This misalignment is a prompting failure just waiting to happen, and it actually did. So consistent naming isn't just a style preference. It's what makes precision and predictability possible. But what happens when you get all your little ducks in a row and you line everything up and the AI still does what AI does? It misinterprets your intent.
That's when we use the IEU framework. Identify, evaluate, and update. We stopped fixing bugs and we started mentoring logic. First, we identified the heuristic by asking the AI, why did you do that? And second, we evaluate the logic gap against our exact design standard. And third, we update the rules engine so the same mistake never happens again. It's like mentoring your junior assistant. But the best part is you only have to tell them that they are wrong for exactly 1 time. So Mike, let's take a look at how we apply this on a real UI bug.
Absolutely. This was a classic one when we were trying to figure out our new workflow. So take a look at this table. On the surface, AI technically thinks that this is finished. But the agent treated the header and the data rows as 2 completely separate layout problems. The columns don't line up, the grid is broken, and to anyone who knows our system, we know that this is immediately wrong. And this kind of error doesn't stay contained. It creates friction, it creates mistrust. And when agentic workflows run without governance, they just don't produce mistakes. They can set governance back further than where we started. So the question then becomes, what do we even do with this? As a traditional gatekeeper, I might update the design file. Jenny might go into the Jira ticket PR and leave a comment for the dev to fix. But an architect needs to understand why this failure happened. not to just fix this table once, but to make sure that it never happens again.
This is the exact standard. The agents must treat the table as one straight vertical grid. The header slots must match the content slots beneath them. So how do we train the AI this invisible rule?
Well, we could use a non-center metacognitive prompt. We could just say, hey, AI, fix this header alignment, and the AI will guess how to fix it eventually. But the same mistake will keep happening again and again and again.
Instead, we use a meta-cognitive prompt. We walk it through the IEU framework. First, we identify the reason why the agents use the wrong number of content slots in the header. Second, we evaluate by explaining that the header columns must match the data row columns beneath them. And finally, we update the rules engine. We encode a permanent rule for auto layout distribution. Because we force the AI to think about the grid and reflect on its own mistake, the same bug will never happen in our system again.
These rules, from something as simple as misaligned table headers to something as more nuanced as our modal button hierarchy, are exactly the type of invisible rules that get lost in development handoff. As a UI designer, I know the visual logic behind our modals. Jenny knows to validate that UX intent in the QA process. But when product teams build pages with core UI components without that governance layer, we generate classic tech debt fast, and it compounds. Suddenly, we're just not collaborators anymore. We're back to being gatekeepers. Without that metacognitive layer, those invisible rules create hours of handoff friction. That's that pendulum swing we were talking about earlier, the endless back and forth that nobody wants, but everybody lives with. Codifying these rules agentically breaks that cycle. It reduces human error in production at the source, and it gives us back exactly what we want: less time correcting and more time perfecting.
Exactly. The meta-cognitive design loop moves us to true self-governance. The design intent is programmatically validated against the exact design standards before an engineer ever even sees it.
And the automatic governance can begin with any idea. A project manager could come to us with a conceptual prototype. The UX team could upload a photo from their whiteboarding session. Jenny could update the BRD, even a single AI prompt. Our process can not only provide those coded prototypes, but it can also send everything back to Figma, applying the auto layouts, theming, and accessibility from the get-go. We are no longer starting from scratch. Instead, we're starting from precision. And the browser becomes the canvas where we apply our final brushstrokes, where governance can truly be directed. When the agent works directly with Core UI and live custom properties, design decisions stop being theoretical. And as veterans who have always worked at that design engineering boundary, tools like Code Connect and A2UI aren't just new workflow improvements and protocols. They're how we close the loop between what gets designed and what gets built.
The business impact of this is staggering. By letting the AI do all the heavy lifting and self-auditing, the projects that used to take us 2 months to build and QA, now it takes 2 hours. And we do it without sacrificing a single pixel of precision.
So here's the blueprint we walked through today. First, create your own BRD agent to standardize your strategy, preventing mistakes before the design phase even begins and bringing QA to the front of the line. Second, ground your AI in an absolute source of truth. For us, it was creating our own MCP, the Core UI MCP, and using Code Connect to guarantee that our design and our code speak the exact same language.
And third, stop checking every single detail. Let the meta-cognitive design loop do all the heavy lifting and self-correcting. Treat the browser as your canvas so that your output is always production ready. And finally, mentor your AI with the IEU framework so that you can encode your rules and you don't need to fix the same bug again and again.
Right, when you combine these tools, you build a shared QA mind. You stop being outnumbered 100 to 1. You stop playing the design police, and you go from being gatekeepers, Jenny, to
being architects.
Yeah. So when the workflow is self-improving and the governance is built in, something is definitely going to shift on your design team. You're no longer handing off intentions and hoping that they survive that development translation. You're actually generating real front-end screens and success, proving design intent before engineering ever enters the picture. And that closes a huge gap that has existed in our industry for a long time. It creates a level of collaboration we certainly haven't seen before at Epsilon. And more than anything, it gives us back our focus on craft, on quality, on the details that actually matter. And we become the human in the loop. So, how do you even actually start building this stuff? Well, luckily, you don't need 60 applications to start. You just need to change how you think about your tools.
We want to leave you with the architect's challenge. First, treat your design system as code, not static pages. Second, mentor your AI. Instead of asking it to fix a spacing, ask it why it used that particular spacing. And finally, build an immune system so that you don't have to fix the same bug every sprint.
Right, encode your corrections. So go ahead and scan the QR code up above if you haven't already. You'll be able to download our exact prompts and templates. And more importantly, you'll have access to Jenny's new AI tool that lets you build your own IEU framework.
We used to be gatekeepers. Now we are architects. We challenge you to build your own QA mind. Thank you.
Thanks.
Wow, thank you, Jenny and Mike, so much. That was great.
Isaac, what does AI, a snake, and a burnt tongue have in common?
AI, a snake, and a burnt tongue. I don't know, what?
No taste. This next speaker is going to show you how to incorporate taste and knowledge into your workflows. Please give it up for Harold Kirschner.
Wonderful. Thank you for having me at Figma. So let's talk about snakes and taste, and hopefully get some more good jokes in here. I'm Harold Kirschner. I work on VS Code, and I'm a PM. I dabble in design, I dabble in code, I dabble in data analysis, all the things PM end up doing. And I did originally write a lot of specs. Who here knew the word or the letters PRD before they became big with AI? So I wrote PRDs. And the problem with specs, they can drive decisions and they can capture decisions, but oftentimes you enter a meeting, nobody read your spec, and everybody asks, like, can we go through it first? And then they maybe last through that meeting, maybe last through another one, but they're not often good at really driving decisions and making something tangible. So when AI really hit the team about 2 years ago, when we started going deeper in AI and adopting it, we saw that prototypes were a lot easier, or even me landing PRs in VS Code directly. Just to make a point, like, this is a good idea, please let me share what I think we should have in VS Code, and we have a PR ready to actually try it out. Then with prototypes, it became a lot easier. If you come into a meeting with a prototype and not a whole spec, you can actually talk about something real. You can talk about something and make decisions. You can bring this back into the next meeting and bring in the decisions from the prior meeting. You can have AI actually apply the discussion from the meeting. There's a whole lot of interesting loops happening. So we have designers making more powerful prototypes, iterating quicker in their tools. We have engineers who actually can quickly spike something, even in the PR and the code base, and PMs making a rough sketch. That's totally AI generated. My sketches are not rough. They're really polished, right? That's my team in front of here. So, way too quiet for that one. So we want something that we can react to. But if something, we're so fast at AI prototyping now, and we're still not often good at getting the output to feel like it's actually our product, because that can help drive decisions. That can help drive the nuance and the craft, that it actually looks and feels right. And this is what I'm going to talk about today, so how your taste and your eyes and your deep context from how your team works, how you can get that into these prototypes. And each of these compounds, once the AI understands your taste, once it can actually use the product, these are all adding on top of each other and making everything better. And it starts by writing down what's in your head. Let's talk about how we bring in that taste so you don't repeat yourself all the time to infuse taste into your AI. So what I'm going to show is how to create a design skill. So if you're not using a design skill while you prototype, you end up with more generic looking things where it doesn't use the right colors, similar to a design handoff where the person getting the design doesn't actually use the tokens but picks colors that kind of look alike. And every session you do in these agents that don't have your design skills, they start from scratch for every person in your team. And there's a lot of tools out there helping with prototyping, and they make really good-looking prototypes. And they might even infuse you with some design tokens so they look like your app, but they still don't feel like your app. So a design system can also bring these things into the skill so it looks right and also feels right. So with design skill, you get all the right spacing, you get all the right carryover, and it's much easier to have these deeper discussions in a daily review. And when I say daily review, I mean it. We have, from the VS Code team, we switched from a monthly release cycle to weekly release cycle, also by having these daily check-ins to continuously drive decisions and unblock people is really part of that game, moving faster with prototypes. So let's look in one of my demo sessions where I worked on a Kanban-style agent orchestration board. And it was just a plain idea I have. We have all these agents now working for us. How do we effectively manage them? The agent nicely went through. This was a custom agent background that is biased towards first doing some research and asking me questions. It actually asked like, what I actually want and what Kanban means in this case. So 4 questions later, it got all the context, and it made a plan. I ran the plan, start implementation, and I made this beautiful Kanban board. Let me just reset it so it starts from scratch. It's amazing. It looks great. There's agents running with different dependencies. They're working on their task. Once they finish and they need some input, they will ask for clarifications and go into need input. Really cool way to demonstrate the idea. But it also looks very, very vibe-coded. We all see the gradients. We see like the typical light colors from Opus that it so loves. Big green glowing buttons. So looks cool, but it doesn't look at all like VS Code. So in this repo, I ended up, after I did some tweaking, I ended up saving everything we talked about. So my questions, my input, everything, all the assumptions the agents made, and all the input I gave. I saved it into spec.md. And it's me not writing a spec, it's just me kind of saving the conversation and saving all the decisions we made into something I can transfer. So it's really a one-pager of what we're trying to do here. Basically, it's the long form of please make me a Kanban board after we talked about it but some more. So now this spec I threw into another repo. New prototype, paste it in the spec, and what I get out after the agent builds it and we do some noodling on it is an actual nice-looking, bigger, nice-looking VS Code-looking prototype that even builds on top of it. So there's some more input elements here. It shows the different dependencies between agents. So this is a much easier way I can now talk about this. And how this works is it's a whole prototyping repo with design skills built in. So how do we get these building blocks in there? What are these building blocks that actually make it possible to make prototypes from just a simple idea that will instantly look like your product, where you can then focus on the details, the little effects, the dependencies, really focus on the experience? One is the agents.md. That's like the root of the project. And these are all markdown files. These are all just files in the repo in this case. So agents.md sits at the root and just really describes the brief of what this project is about. It infuses it with, it's a VS Code prototyping repo. Think about VS Code. It's all about prototyping. It's the always top of mind for the agent. Every request you make to the agent, this agents.md is in its top of mind. Then the second one is skills. And those are just markdown files with a description on top that are loaded on demand when the agent sees specific workflows that match the description. So you can have multiple skills. You can build a whole skill database for review, for prototyping, for different workflows that you found useful in the past. And most of the time, I have the agent save a workflow, just create a skill for this thing we just did, and then tweak it from there. But it's a really powerful way to build these reusable kind of knowledge bits and workflows and share them across the team. Lastly, we have instructions. And instructions are similar to skills, but not included based on workflow, but based on files. So they allow you to describe specific areas of your code base and how the agent is supposed to work on these areas. So all of these are agents.md is always loaded, and then skills and instructions are progressively disclosed to the agent. So it knows that they exist, it knows when to load them, but it will only ever look at the full file once they match a specific pattern that the agent is aware of. And for all of these, you want to think about size, because they all end up using tokens. So it's always a good exercise to figure out, is your agents.md minimal enough, and just really captures the essence of what the agent needs every time it works on your project. So let's see what this looks like in this prototyping project. So I could browse over here. They're all in the GitHub folder, in my case, for GitHub Copilot. But just open up our agent customization view. So first one, the most important one I mentioned, is the instructions one for agents.md. So it's pretty straightforward. This is all there is. It's and the best secret is that this is about it's kind of these extra lines. So I kept tweaking it. I created a prototyping repo, and then I kept tweaking it because the agent kept making these things like, oh, I'm going to change this. I'm going to add a migration because we have this old behavior, and you need to have the new behavior, and we need to support both. No, this is a prototype. We're going to throw out the old behavior. I'm going to move over. This is all throwaway code. I want to move fast. I want to be iterative. I want you to apply a prototyping mindset. So this is all that the agent needs to know always when it works in prototype, is that it's working on VS Code features, UI concepts for VS Code. And then over time, I evolved a bit more of these development principles to not think about how we're going to ship this, not think about too far ahead. It's really about focusing on the UI and the experience and the problem. Similar how you do a brainstorming, similar how you do a design thinking workshop. All of these things are really important for the agent as well, because otherwise it's biased towards shipping production-ready code, hopefully. So that's the agents.md. Then let's show one of the skills, the design system skill. It's a pretty simple one, and it doesn't capture the whole design system of VS Code, but enough to make the prototypes look good. So one of the easiest one, I actually pointed it just at our folder for our latest design theme on GitHub, and it extracted all the tokens, the spacing, all the important stuff. I also gave it access to our code library, to our Codicon library. So the Codicons are all the icons that power the VS Code icon system. And that's like an instant win to make every prototype feel much more like VS Code that actually uses your icon design language. So we got color palette, we got typography, we got a hierarchy of headings, we got depth, we added some shadows lately, and some corners, and translucence is in this new design system as well. So all these, just the combo of this, leads to instantly recognizable VS Code design. Not perfect, but close enough. So lastly, we have the file-based instructions. And one interesting thing with this prototyping system, I added a design.md system to every prototype because I find I can talk through a prototype and noodle on it and give feedback and iterate on it. Let's move this over here. Actually, the agent, you misunderstood me. This was not the problem we're trying to solve. We're trying to solve the other problem. But all of these things end up not visible in the prototype. The journey is hidden away if I just show people the output. So what is a good artifact I can actually create along the way? It creates these design.md files. So I can go in here and actually open up the design doc and read about everything we did doing this process that when I worked with the agent and collaborated. So it's kind of transmission log between us and what we decided on, how the agent understood me, what I gave as feedback, and all these things can then inform the next conversation, which isn't necessarily just a prototype. So it's a really cool system, and that design.md file is defined here in how it's structured, in what is in there, and how to update it. So these are the systems that make this whole thing work. But how do you share them? Now we have a really cool design system file, and it's in this repo. So that's step one. Everybody downloading this repo, which is, by the way, also open source. You can just get it on GitHub. And everybody who checks this out will now get these skills. So the agents.md file, it just works out of the box. But sometimes you want to then bring these skills that work really well in one repo and for one team across more areas, maybe multiple teams, the whole company. And that's where team-level plugin marketplace show up. In VS Code, you can actually browse the plugin marketplace right here in the UI. I go on plugins, browse marketplace, and we have the Copilot plugins built in, awesome Copilot. And lastly, I have my own plugins all the way down here from the VS Code Team Kit. So the VS Code Team Kit, again, an open source repo on GitHub. You can check it out. It's where we share code reviews, things, and GitHub triage, and other places that we like as a team that makes us more productive, and let everybody else use it. And it's open source, so you can also use it as well. But it allows you to connect it to any of the coding agents you have for discovery. And when you update them, everybody will also get the updates. And that's an important part. You want to keep those things updated. That maintenance, treating them like infrastructure, because those are prompts that agent harnesses and models need to interpret. So over time, as models update and as agents update, these skills will work better or worse over time. And some of you users might have an idea like this, I changed this line to you must always do this, and it fixed all my problems. And then you will have these philosophical discussions on prompt crafting if you don't have evals in place, like you do with every agentic infrastructure, to prove that the improvements actually work. So it's really important to maintain skills, to treat them as infrastructure, to not have them drift over time as you update models and harnesses. Your team might use different harnesses, and you have a proper conversation around quality. So now the agent knows how to work with your design. How do you actually let it look at what it's building to take more action? So in VS Code, we have a built-in browser. I just showed the websites that you already used to preview, and the agent can actually use the built-in browser. And that's the most powerful thing I recommend to everybody working on any user-facing or any front-end application is finding feedback loops that your agents can use your application. We've been doing that in VS Code in automated ways. When we fix a front-end bug, there's actually in the PR, we have an agent running that takes multiple screenshots from VS Code because it's a web app and reports back on what changed and what got fixed. So the built-in browser is one way to just get an out-of-the-box eyes on your application by the agent, and it can iterate and fix. If you work on native apps like Xcode or iOS, then you can actually use Xcode Build MCP as another example, which I'm a big fan of. And it's quite magical to have the agent just bootstrap a full application, then open it and browse through it and take screenshots and give feedback on its own work and tells itself how amazing it did. So it's one of these really cool experiences, but also makes it much more hands-off that you stop constantly testing your own app, but the agent can actually run through it. And lastly, if your platform isn't in here, there's probably an MCP out there or a CLI that allows you to do that. But it's something to really invest in, that once have it in automation, but also have it locally, that you can have the agent iterate over your actual application and look at it. But how does it actually do that? Like, what do you tell the agent what it's supposed to do other than, like, please look at my app, does it look right? So the does it work question is the basic one. That's the most functional one, where the agent will give you feedback on accessibility, maybe a button isn't working, maybe something else that doesn't feel right in the application or that feels like an actual bug. So that's like the quality assurance experience. But the other experience is give it actually a persona. Like, how would a new user with that kind of background experience the app? And agents are amazing. LLMs love behaving like a different persona. In the beginning, we gave it all like, you are an expert software engineer, you're an expert designer, designed in human guidelines and everything. So treat it like, give it the persona of a new user that's critically evaluating your application, and they have these needs. All your user research that you've been doing can feed into these personas. And you can get really good feedback from the agent, and new thought processes will be unlocked by this. And that's like the last one as well, like push yourself to be more of like, how can you infuse a skill or a dogfooding agent with something that's really, that gives it the right mindset. Like, I like the one where I give it my vision document or my pitch document, and then just have it look at like what I'm trying to achieve, like what is my promise with this application, and then you're a critical dog fooder that gives really deep feedback, you're honest, you're brutally honest, tell the AI to be brutally honest and roast the application, and you get better feedback. And the agent will go deeper as well. Because it's a critical dog food, it will follow up a little bit more and do a little bit deeper dives. So how does this look like in action? So the skill we're looking at, go look over here, is also a skill in our prototypes repo. It's my favorite dog fooding skill, a sharp, independent dog fooder. But it's grounded in the design.md file I showed before. So it understands kind of what we're trying to do with this prototype and what's the problem, what is the user, what is the context, it's all in. And so it first looks at the design.md, really tries to reason about what is it all about. And then it opens the application, takes screenshots, walks through the user journey that it kind of extracts from the design.md, and structures the feedback. So you can find this all in the repo, again, open source. So it did that over in this session. OK, so it went through, it took screenshots. You can see all the screenshots it took over here. It did how many times it ran through, and then, but in the end, I could read a long chat, or I could actually give it a nice visual summary. So it's been pretty rough when I first ran it, but you get the idea of it's giving feedback, very honest feedback. OK, lastly, we have the product brain. Now put it all together, put it into a repository, your evidence that you did research on, your prototypes, and all your decisions. Create different agents like design partners and feedback synthesis that gives you more feedback, more pushback. And it all compounds over time with agents, skills, and evidence. Put it all into one repo, and I have a link here as well that you can try this out. So it's your taste, your eyes, and your context. And the teams are not winning by using more AI tools. It's all about the context and making your taste visible to the agent. So when you come back home, write an agents.md, create a skill for your designs, and keep iterating. Thank you.
Wow, thank you so much, Harold. Way to close things out with a bang.
And let's hear it one more time for all of our incredible speakers today.
Yeah, we're officially done here on level 2. Thank you all for being such an amazing audience. We can't wait to see you tomorrow.
We hope you had an amazing first day of Config. See you tomorrow morning.